So, hey students, and welcome to our session today on TCS Digital Training. So, let's begin without any delay. So, in TCS Digital Training, so far we know that this entire training questions that will be asked when it comes down to coding questions are going to be based on slightly advanced concepts. It's not just basic things like print a series of numbers, or it isn't just a basic question like print a pyramid of numbers. It's not just such a simple question. What will be asked is going to be a slightly complicated question compared to this. So let us go ahead and try to figure out how to solve these particular questions. Now, I assume there's a slight issue in displaying my screen. So let me just try to share the screen so that it is visible to everyone and we can begin right away. All right, so I hope and assume it is now um, you're able to hear the audio from this side. I hope you're now all right. Perfect. So it was just that I had to put up two screens together. I hope you're all able to hear the audio now without any issue. So now that it is clear, let us go on and start with the very basics of what we can expect when it comes down to TCS Digital. So I'll repeat the couple of points that I stated earlier. In TCS Digital, you will not expect something like print a series of numbers or print just a pyramid of numbers. What you will rather expect here is some programs which are generally related to dynamic programming or advanced mathematical logic, or string programs which may involve permutations, combinations, or anagrams, and so on. These are some kinds of programs that you may expect. Apart from this, you will also expect programs particularly on matrices, that is programs which use concepts like Kruskal's algorithm or Prim's algorithm and so on. So the best thing to work on when it comes to TCS Digital is always to learn your data structures and algorithms really well. So there are a lot of data structures that can be used in programs that may generally be asked. Things like linked list or stacks or queues and so on. You may expect some simple questions on these, such as postfix expression evaluation or prefix expression evaluation or expression validation. Such questions can often be expected. So that is one thing that I would suggest all of us should know, because when it comes to TCS Digital, I'll repeat this most important point before we start going to programs. The programs you may expect are not just going to be something simple. You're going to expect them based on all of these. So in our session today, what we will be doing is looking at what exactly is dynamic programming, and we will also look at how we can use dynamic programming to solve problems, because in some cases of TCS Digital, if you don't solve a problem using dynamic programming methods, your program will get this error called time limit exceeded. Dynamic programming is basically used to execute or run certain programs in a faster way, which helps make sure that your entire program runs by taking less time and less memory as well. So we're going to look at this and try to figure out how to solve such time limit exceeded or memory limit exceeded errors that we get without dynamic programming, and we'll see how dynamic programming solves such error. We'll begin with our first program, that is a simple Fibonacci series. We already know this, and yes, as one of you stated in the chat, competitive programming, absolutely correct. We will look at this in terms of competitive programming and try to learn how to basically solve so that such errors will not be encountered by us. We'll start with something simple such as Fibonacci program, and we will learn how to make it dynamic, how to use dynamic programming within it instead of a simple brute force technique that we learn in our labs and in our engineering days. Followed by this, we will go on to a couple of programs, particularly that is knapsack problems, and we will also look at a couple of sliding window problems which are often asked when it comes down to these sort of interviews. And I will also point out what kind of particular questions can be asked with these and how exactly do we solve them. So without any delay, let's go ahead and begin. So students, the first thing we need to know here is the kind of questions you may possibly expect. And now that we know this, let us go ahead and look at what exactly is dynamic programming when it comes down to this. So here's the basic idea. Dynamic programming is where I'll just try to write down a few statements, all the programs, everything that I'm writing down here. I will be sharing the link of this file by the end to you guys, so you can also access the same if you want to go through the same programs later on. So dynamic programming is basically an optimization technique where you try to make sure that whatever the program that you're executing gets executed in a shorter time by a particular method, that is we store sub problem solutions in order to make sure each unique sub problem is executed only once. I need you guys to note this very clearly. The basic idea is that we're gonna try making a problem or dividing a problem into sub problems, and once we divide that, each sub problem is basically unique and it should be executed only once, not more than once. So to understand this, let us take a very quick example. So think of this, students. We already know how a Fibonacci program works. In our regular Fibonacci program, if let's say we had something like your main function, and you had something, let's say Fibonacci function, which will return the nth Fibonacci number. So we already know how to do this. If n is less than equal to 1, that is, generally we can also say this as if n is equal to 0 or n is equal to 1, we return n. Otherwise, if it is non-zero and non-1, it is any other positive value, we basically return Fibonacci of n minus 1 plus Fibonacci of n minus 2. To make it easy for you guys, I'll just make sure that the rest of this term is just removed so that we only see it as Fibo. So the nth Fibonacci term is calculated by returning Fibo of n minus 1 plus Fibo of n minus 2 until we get the values either 1 or 0. If we get 1 or 0, we basically return the same number. So here, if I need to find fifth Fibonacci number, now the reason I'm going through this example is just to show you guys how flawed this program is when it comes to time and memory efficiency, and how we can improve this. This will give you guys a really good idea on how exactly dynamic programming works. So think about this, guys. Take the number 5. I need to find Fibo of 5. So the first thing, when we call the Fibonacci function with n as 5, it's going to return Fibo of n minus 1 plus n minus 2, because n, which is 5, is neither 0 nor 1. So we already know this is going to return Fibo of 4 plus Fibo of 3. Similarly, Fibo of 4, we know it's going to return Fibo of 3 plus Fibo of 2. Likewise, we also know Fibo of 3 is going to return Fibo of 2 plus Fibo of 1. Likewise, we can keep on calculating here further on. Fibo of 2 will become 1 plus 0, then 2 here also becomes Fibo of 1 plus 0, and so on. Now on the right side, Fibo of 3 is calculated again. We already have calculated it here. If you guys see, particularly here, we calculate Fibo of 3. I'll just try to highlight this. This is exactly where we calculate this. So why do I need to calculate it again here? In our recursive function, we are calculating it here as well and here as well. So that's basically spending extra time to do the same sub problem again. We are solving the exact sub problem multiple times here, and no matter how many times we solve it, we know the answer we're gonna get is basically the same. It is not gonna change. Fibo of 3 is gonna remain as the exact same output. So what we can possibly do is execute it only once and store the result. Execute it just once, and we are gonna try to store result of all sub problems. These are the sub problems. Remember, guys, to calculate Fibonacci, that is fifth number, I'm calculating Fibo of 4, Fibo of 3, Fibo of 2, Fibo of 1, everything. What if, since I'm calculating Fibo of 5, I'm just gonna do this. First thing I'm gonna do is calculate Fibo of 1, then Fibo of 2, then 3, and then 4. Once I calculate Fibo of 1, 2, 3, and 4, Fibo of 1 is first term is, let's just call it as 1 for instance. Let's say first term is 0 for instance, second term is 1, and third term is 0 plus 1, which is 1, fourth term is 1 plus 1, which is 2. Let's assume this is the case. Now if we know this already, the moment I calculate Fibo of 5, it's gonna just go to Fibo of 4 plus Fibo of 3. I don't have to calculate everything recursively again. So this is the basic idea of dynamic programming, which makes it faster, each subproblem, each unique subproblem is solved only one time. So one time we calculate fib of 3, we don't need to calculate it again. In recursive case, we needed to calculate it twice, one under fib of 4 on the left side, another under fib of 3 on the right side. So this is basically the idea of dynamic programming. Now that we understood what exactly is dynamic programming and how do we try to solve this, let us look at what are the ways to do it. So guys, and this is hugely important for us to solve any such questions, because even if you don't know any algorithm, once you know the idea of dynamic programming, you can try solving it by yourself. So let's try to figure out. There are two ways to work through dynamic programming. One is called memorization and the other is called tabulation. Tabulation is basically a bottom-up approach. Memorization is just a top-down approach. Now, what exactly are these? Like, if you're from a different branch or if you have not noticed this a lot, what is this and how are we going to try to work through this? Here's the basic idea. When you try to look at something like memorization, which is a bottom up approach, you're trying to figure out the smallest sub problem and solve it. After solving smallest sub problem, you're going to try to go solve bigger sub problems. For example, in Fibonacci series, I'm going to calculate Fibonacci of 1, then I'm going to calculate Fibonacci of 2, then I'm going to calculate Fibonacci of 3, which is easy to calculate once the previous one is calculated. So like this, I'm doing from lower value to a higher value. When it comes to sub problems, this is your bottom up approach. That is basically you're doing smaller problems first. F of 1 which leads to F of 2 which leads to F of 3 and so on. Top down approach is called tabulation, which is also used in many cases where you do or you solve a higher sub problems first, then divide it and go down into smaller sub problems. So this is the basic idea. So let us look at what are the methods here. So once I talk about the methods here, you guys may remember that you have seen this already in your lab, possibly in your first year or second year in your engineering. So when you talk about memorization, that is sorry guys, I just wanted to note one thing. Please note here, when you talk about memorization and you talk about something like top down approach over here, this is basically what you do. You divide the problem into smaller sub problems, solve each of them, then solve smaller sub problems, and so on and so on and so on. So I'll just point this here, guys. Please note this. Memorization examples of this are things like divide and conquer. You're taking a bigger problem, you're dividing it into smaller problems and then solving them. You're not taking a smaller problem and then combining it at the start. You're taking the whole problem and dividing it. That is basically memorization. Tabulation is the very opposite of it. You're going to start with the smallest cases and you're going to start combining them. So let us try to figure out how we can solve this exact Fibonacci program, or to find out nth Fibonacci number using dynamic programming. So even in TCS Digital, let's say you get this question itself, find nth Fibonacci number. You try this, it's going to give you time limit or memory limit exceeded error. The reason is that they particularly expect you to solve it only using dynamic programming. So to do that, here's our basic idea. Think about this, guys. All that we need to do is create a table. In that table, we just need to have Fibonacci of 0, Fibonacci of 1, and so on until n minus 1. Once we have it, we can start solving this. So let us try to figure out how exactly can we do this. Now most of the programs that I will be solving will either be through C++, or Java, depending on the requirement for the program. For dynamic programming, if you guys know Java, it is always preferred, because with Java you guys are gonna have some inbuilt collections that you can use. If you don't know Java with collections, not a problem, you can also use arrays or something like that in C or C++ to solve the same. Now I've just received one of the questions in chat to just specify what question are we solving. We are trying to solve Fibonacci number. We are trying to find out nth Fibonacci number only using dynamic programming. So let us begin this program without any delay. All that we need to do here, guys, please observe, is to just create a table of these numbers. Once we create a table of these numbers, when I want to calculate Fibonacci of n, I just need to calculate n minus 1th Fibonacci number plus n minus 2th Fibonacci number. That's basically all I need to add. I don't need to calculate everything again and again recursively. That's the advantage. So let us do this. So the first thing I'm going to begin with is here, guys. Please observe this very carefully. It's a pretty simple and small program. Any questions, any doubts you may have in this, you guys can feel free to ask. So the first thing I need here is, when this program starts, I need to create an array which can store 0 to n minus 1, or 0 to Fibonacci of n minus 1, and all I need to calculate is Fibonacci of n minus 2 and Fibonacci of n minus 1th value. So assume this, guys. If I want to calculate Fibonacci, that is 5th Fibonacci term, all I need to do here is just take an array, let's say index 0, 1, 2, 3, and 4, and here all I need to do is calculate what is Fibonacci of 0, initially 0, Fibonacci of 1, that is index 1 is initially 1. From index 2, I just need to keep adding them. That is index 2 will be index 0 plus 1, which is going to result in 1. Index 3 will be index 1 plus index 2, which is going to be 2. And index 4 will be index 2 plus 3, which is basically going to be 3. Now you guys are able to understand the entire program with this simple logic. Once you have done this, once you have created an array of this, all you need to do is just add these two values. After adding, you just need to print. That's basically it. Now there may come a question. So isn't this gonna take more memory? You're creating an array. Won't it take a lot more memory than how you would do without dynamic programming? Think about without dynamic programming. You're calling recursive functions. When you call recursive functions, the function is going to call itself again and again and again until many functions are stored within your function call stack, or as I stated in short, FCS. Since many programs will be, or many functions recursively will be stored in function called stack, it is not easy for us to go through everything in such a way that it is memory and time efficient. So that also has its own disadvantages. So let us try to solve this as quickly as possible. So all that we need to do here is get an input n from user. So I'll just use scanf %t comma ampersand n. So to everyone, let me just point this out in short. When it comes down to these interviews, I'll just save this file as well for our session. I'll just save it as, let's call it as program.c. So any input that you may expect, you don't have to write something like printf enter the input number or something like that. Don't write anything. Only write on the screen what they're asking. Except for that, don't use a single space slash and whatever it is. Only print what they're asking. Except for that, please don't print anything else. that may make the compiler think your output is wrong, because the compiler only checks what is your output over there. So once you have read the input value, the next thing you need to do, remember guys, if I've read input value as 5, I need to create an array of 5 elements. So let us try to create an array of 5 elements. So to create an array of 5 elements, we're going to take the same function int fib of int n, and we're going to create the array here. So we'll just call here fibo of n. So n is the value which is sent. Let us assume 5 is sent over here to the function where we are receiving it as n. So all that we need to do here, guys, please observe this very carefully, is to just create an array. Now if you create something like int a of 100 or something like that, then that's a problem. What if user enters less than 100 elements, user enters less than 10 elements or something? Memory taken is too much. What if user enters greater than 1000 elements? Memory taken is too less. So you need to create your array using a concept called dynamic memory allocation. For those who don't know dynamic memory allocation, you can just check out basically how malloc and calloc works. So I'll just use malloc directly over here to create this dynamically. So I hope till here everything is very clear. So let's go ahead from here and try to basically learn what exactly will happen now. So the first thing here is, in order to use malloc or calloc, I need to include a new header file called standardlibrary.h. So once we have included this header file, I don't have to create an array like this. I just have to use malloc function to create an array. I'll just send in malloc size of array. Now in my case, size of the entire array is not 5. It's not just 5, because each integer takes either 2 or 4 bytes depending on size of compiler, and this 2 or 4 bytes you have to multiply it by 5. So what we will pass into malloc is basically size of int multiplied by number of elements, so we get the total number in bytes that will be allocated. So let us do the same. So we'll just send number of elements into size of each element. So once this is done, since it's an integer array, we need to store the resulting value in an integer pointer. We'll just call it as int star fib values is equal to int star. So we're just knowing that malloc always returns void pointer, we are converting it to int pointer and storing it here. So this means when you create an array of 5 elements, fib underscore values is the variable or is the pointer which stores starting address of the array. So it stores starting address of the array. Let's say starting address is 100. This basically stores 100. So you can access it just like a fib underscore values of 0, fib underscore values of 1, of 2, of 3, and so on. That's the basic idea. So all we need to do here is just one simple for loop. So we'll just take int I, and as we know, fib underscore values of 0 should always be equal to 0. Fib underscore values of 1 should always be equal to 1. Once this is done, all that you need to do is use a for loop for I equals to I less than n I plus plus. I'll tell you guys the reason why I'm using this for loop. Think about this, guys. We already know 0th value, that is 0. We already know first value, that is 1. We need to go from index 2 until index n minus 1. So that is why we are creating a loop to go from index 2 to index n minus 1. So all we need to do calculate here is fib underscore values of I is equal to, can you guys guess and let me know? I'm just gonna give you guys a few seconds. Think through. Fib underscore values of I should store what exactly? Right, we're supposed to store fib underscore values of I minus 1 plus fib underscore values of I minus 2. So once we have done this, we have created our entire array, and all we need to return here back to the user is sum of, let's say 0 plus 1 we get 1, 1 plus 1 we store here as 2, 1 plus 2 we store here as 3. All we need to do to calculate fifth Fibonacci number is just this. Know that the index is 4. Please note guys, index is 4, but it is storing the fifth Fibonacci number. So we just send this back to user. We just return fib underscore values of n minus 1. That's it. Once it is done, you're getting the final value here. Let's say we store it in something like int I, or you can just, instead of storing it in another variable, just print percentage %d. I'll just use slash n comma fib of n. Let's see if it works correctly. I'm just gonna run this program. First let us compile it. Let's see if it works and what test cases we need to calculate up here. So let's compile it. Once it is compiled, there's no error. Let's execute it and enter an input, let's say 5. So fifth number it's giving us 3. Let's see if that is correct. That's absolutely correct. We've got it. So now, if this is correct, where do we go wrong? This still is not perfect program. There's still some test cases which may not work properly. So what are those test cases and how exactly do we solve it? So let us try this out. So the first thing we need to know here is, what if user enters a non valid input? So most of the times when that is the case, you need to print invalid output. That is, you just have to specify if n double equal to 0. See, when n is 0, I don't want it to go here and calculate anything. I just want it to print directly 0. So you can just say if n equals 0, print 0. That's basically it. End of the program. No need to worry. Else if n double equals 1, you don't have to go find in the whole array again. You can just print 1 slash n. You don't have to create an array again. Only else you have to go through this. Now before you go through this, there's one more condition. Else if n less than 0. If n is less than 0, you have to print, let's say something like invalid input. Once that is done, then you finally go for else, that is to print the value. So these are the kind of test cases which you need to follow. And in the question, if they say input number will be something like 1 less than, they will state that input will only be positive. It will be something like 1 less than equal to n less than equal to something like 1 lakh, for instance. If that is the case, there are some other problems we may expect in our programs, and I'll tell you guys what could be the problems. One is, in your program you may not be able to store an array of so much length. If that is the case, what exactly do? We would need to use the concept of a linked list. Now if that is the case, in C++, you have an inbuilt library to use linked list. In Java, you have collections to use the same as well. So the same can be done here. Or if you really want to save much more memory, you don't even have to create it as a table. Once you know the nth, that is the input, which is 5, all you need to create is just 3 variables. Remember guys, just 3 variables. Just have themselves keep updated. Like for example, 0, 1 and 1. So let's say these are the 3 variables. Let's call it as A, B and C. First, calculate sum of a and b, add it into third variable, increase count, saying that you're now finding third Fibonacci number. After this, take 1 and 1 here, increase, and store the result here as, let's say, 2. Again, increase count, then take some of this, store here, and keep on doing this in a loop. Even that will work. Since we have to go through some more advanced program, I will not be going through every logic of this, but I hope you guys are getting an easy idea how we can solve this without even creating an array. You basically need just 3 variables with another count variable, where you just have to loop or perform while loop with these 3 variables. So I hope and assume you guys can easily do this without any difficulties, because we have tried a very similar program and this is not too difficult compared to it. So you guys can let me know through the live chat over here in YouTube whether you guys can easily do this or you want us to try it out. I'll be going through the majority of responses from you guys. So followed by this, since my stream may be delayed to reach you by 15 to 20 seconds, once I've asked the question, I may expect a response possibly a minute after it. So if you guys do want me to do it, I'll be only able to read it a minute after asking. So we can do that once you guys respond with a yes. But anyway, let's go back here and try to go ahead with the next part. I would assume you guys already know and feel like this is simple. It's a simple logic. We don't need to go through that. We can try it out by ourselves. Unless you want me to do it, you guys can let me know. So let us now go ahead with this over to something else. Now that we have the idea of what is dynamic programming, if such program is asked, how can we solve it? The basic idea, I'll repeat, please know this guys, every sub problem is solved only once. Unique sub problems are solved only once. You don't need to solve them multiple times. So this is the whole idea. So now let us go for a common question that has been asked multiple times here. Before that, I'll just copy this program for your reference and I'll just state that same program can be solved using just 3 variables without the need of an array itself. So assuming that this will be very easy for you guys to solve, let us now go ahead. Okay, I'm getting responses that you guys will try it. Perfect. All right, so let's now go ahead to the next kind of problem that can be asked, which is often asked, something called maximum average sub array problem. When you talk about this thing called maximum average sub array problem, they're going to give you an input array. So first input will be n, which is number of elements. After that, you will get an input of all the elements. Then n elements are entered. You need to find, apart from this, one more value k will be entered, which is the length of sub array. So think about this guys. Let's say something that is entered here is, let's say input is 5. That means they're basically going to enter 5 elements. These 5 elements, let's say they are 1 2 3 4 5. Let me take 6 elements instead. Let's make it a little lengthier so we can understand the logic better. So let's say this is n. The moment n is entered as 6, they're going to give you 6 elements. After that, they're going to give you another value k, which let's say is 4. So k is the length of sub array. You need to find what is the maximum sum of the sub array. Now I'll also tell you guys in what different ways this question can be asked and how do we end up solving it. This particular question has been asked in multiple ways and it's something that's very easy to solve as well. So let's try this out guys. If I need to find maximum sub array which has, in other words, subarray of length 4 which has maximum sum. When I take 1 2 3 4, I get one sum, that is 4 plus 3 plus 2 plus 1, I basically get, let's say, 10. Then if I take 2 3 4 5, you're getting one more sum value, that is 5 plus 4 9, and then 12, and then 14. Then when you try the same for 3 4 5 6, you're going to get one more sum, which is basically 18. And since this length 4 sub array has the maximum sum, you can say that maximum average, sorry, maximum sub array sum is 18. Or they may also ask you, instead of maximum sum of the subarray, we need you to calculate a maximum average of subarray. So any such question can be asked. If it is maximum average, we need to calculate the result in a float value. So if we need to do this, let's think about this. There are n elements and there is k average, k length of each sub array. So I need to take first k length, I need to take second k length, and I basically need to take third k length. So you're gonna have to do this n into some amount of times. So this takes a higher time complexity. And to top it off, our entire definition of dynamic programming was that we should not solve one sub problem, one unique sub problem more than once. So let us try to figure out how not to solve this sub problem more than once. This is where we use a concept called sliding window. So let us try figuring out what exactly is this and how do we solve it. Let's take the same example. 1 2 3 4 5 6. So let us initially start with 1 2 3 4. So we get to know that adding this is 1 plus 2 plus 3 plus 4 is basically the value we get. Similarly, once I try for the next one, we know for the second one what I'm getting is 2 plus 3 plus 4 plus 5. And for the third part, all I'm getting here is 3 plus 4 plus 5 plus 6. So what we can observe here is, in the first case, I'm adding 2 plus 3 plus 4, which is again added in the second case. In the second case, I'm adding 3 plus 4 plus 5, which is again added in the third case. So you can basically say that there's a sliding window which passes here. The sliding window is at 1 2 3 4 first. The moment 1 2 3 4 sum is calculated, the window should slide over to the next values. Once that is calculated, the window should again slide over to the next values. So this is basically the sliding window problem. Now I will also explain in what other ways same kind of questions can be asked. Sliding window problem itself can be asked in multiple ways when it comes down to interviews. So I will also go through all such unique questions, but before going through that, let us figure out how to do this. So first time when I calculate 1 plus 2 plus 3 plus 4, I need to keep the result of 2 plus 3 plus 4. Next time, I just need to make sure that when I move this, I have the result of 2 plus 3 plus 4. I'm just subtracting 1 from this and I'm just adding 5 from this. And when I go ahead, I'm just subtracting 2 from the sum and adding 6 to the sum. So the number of calculations we are doing are drastically reduced. So this is the basic idea. So let us try to solve one such problem, and once we do this, we will get a much better idea of how to solve such problems in multiple cases. We will also see in a similar way how to solve this when it is strings, what sort of questions can be asked, and so on, because this sliding window or staircase problem in some different modifications can be asked in many ways. So I hope the idea of sliding window is clear to everyone. So if there are any questions within the idea of sliding window itself, you guys can feel free and ask whatever it is the doubt. if there is no confusions within the idea of sliding window, I'll just move ahead to the next part. Again, I'll repeat, anyone can basically ask any question whatsoever within the realm of these concepts. If you have any questions, any doubts, any confusions whatsoever, so let's go ahead with this. Now the first thing that we're going to start here is we need to calculate, knowing how much is the length of the array. We need to figure out sum of first k values, then we increase by 1, make sure that the last, we have not reached last value, we need to find sum of this. If this is greater than sum of the previous one, then do the same thing again by increasing this and making sure sum of this is greater than sum of the previous one. Only if it is greater, we go ahead, otherwise we don't. So that is the basic idea. So now that we know how to do this, let us try going through the entire program. So now remember guys, the time complexity we're gonna find out in the program we're gonna do, the time complexity is gonna be much lesser. So let us do this. No, since we did the previous program in C, we can do the next program in C++ to see a little bit of difference. And one thing I would always suggest for anyone who is working through C++ is learn this particular header file, that is bit/standard C++.h. This is a very useful header file which has a lot of functionalities. So if you guys are interested, you guys can go through and check out what exactly it does. For now, we may not need it, so I'm not going to implement it right away. Instead, we're just going to go for our simple trusted IO stream, and we're just going to use the namespace standard. So let's start with a very simple case. I'm just going to start with int main and return 0. So here we need to read 3 inputs. So please note and observe this very clearly, guys. We need to read 3 separate inputs. And those 3 inputs are, first, number of elements, then we need to create an array of size n dynamically. So if you guys want to use standard library.h, in this you guys can do it in a certain way. Let us see what errors we can expect if we don't do something properly as well. So I have one question by the time, that is, I need both largest and second largest values at same time. So if you want to get largest and second largest values at the same time, you can use a single for loop to do this. That is, okay, I have one answer by which states we can take we can bubble sort and take sum of k elements. All right, at Rudra's question, yes, you can do bubble sort and take sum of last n elements. Here's the problem. To perform bubble sort, n square is the worst time complexity. Do you want to go n square times? Because you're going through the for loop one time, and within that you're going through for loop of the entire length of the array again. So if the length is n, one for loop within a for loop, n times n, it's basically coming up as n square. So this is a huge time loss. So to solve this, we don't want to go through so much time. That is the basic idea of dynamic programming, and this is the reason why we are going to use this particular concept. So let us go ahead here and try to figure out how to solve this particularly. So the first thing that we're going to do here is have the user enter an input n. So let's just read something again. Since we basically most of us know only C as far as what I've received as well, I'm just gonna go for stdio.h and hash include standard library.h as well, and work the same thing in C. So we're just reading one input, that is n, and once we read this, all that we need to do within this function is create an array which can store n elements. Now we're going to do the exact same steps as we did earlier. No, we're not even going to do quick sort. I have one question from Pratyusha who says we can do quick sort. Yes, quick sort gives you something like big O of n log n as the time complexity. I don't even want n log n. What I need is only n. I don't even want to go to log n. So to make sure that we do it in the smallest time possible, we use this. And of course, some of you may say we can sort it and work around this. Yes, but when I go for a few different modifications of this program, you can't solve those modifications using sorting method. That's something you need to do only using this dynamic programming method. So we will also see what are such programs and how to solve it. So let us create an array of n elements, and since we need to store the result in a pointer, I'm just going to take int star p. We're just going to store p is equal to int star, let's say malloc of size of n into size of int. So we have already gone through this function. It's not something new to us. So once we do this, we get the starting address of the array which can store n elements. Now we need to read all the elements, all the n elements. So we'll just take another for loop, and now we need to take a variable I as iterative value. So we're going to create one more variable called I. We're just going to make it as for I equals 0, I less than n plus plus. All that we do here is read percentage d comma ampersand p of I. So from p of 0 to p of n minus 1, we're basically reading here. Once this is also done, we have read our first two values. We only need to read one more value, that is k. So let us use scanf to read even the variable k. So once we have done this, we have read all the variables that we basically need to solve our program. Now that we know the array, we know the starting value and everything, let us try solving this. Here's the thing, guys. Observe this very clearly. I'll give you guys the simple clue, the simplest way to solve this. Given an array of length n, you need to start first k elements in such a way, I'll repeat this, please note students, in such a way that if you're starting with index 0, you're ending with, I'll point the indices as well. And remember, I'll tell you guys why exactly I'm pointing indices. It's because when you're done with indices 0, 1, 2, 3, then you go for 1, 2, 3, 4, then you go for 2, 3, 4, 5, and when you go for 2, 3, 4, 5, you need to know when to stop. And to know when to stop, you basically need to know where your array ends, because if your starting index is k in such a way that, or it's, let's say starting index is I in such a way that I plus k, remember k is the length of the sub array, which is 4. So I is index 2. So when you add 4, or in other words k to it, when it reaches n, number of elements we have is 6. When it reaches n, you need to stop. So basically what you're doing here is performing this exactly n minus k times. You're going through this n minus k times. So your worst complexity is only big O of n minus k. It's not even n. So this is why it's much faster, especially when you start looking at larger values. So let us do this. So I have to keep on looping this for I equals 0. Then initially, observe this, guys. I is initially 0. That is the starting index where we need to take sum of k elements. Then I becomes 1. Even there we need to take k elements. Then I becomes 2, where we again take same k elements. When we reach I as 2, we stop here because here I plus k is equal to n. So the condition here is when I plus k is equal to n, we stop. So let's have a condition here for I equals 1, I less than equal to, I'll repeat this guys, sorry, not I less than equal to, I plus k less than equal to n. So when I plus k becomes equal to n, that is 2 plus 4 is equal to n, that is the last case. You don't have to do anything more than that. So your condition is I plus k less than or equal to n. When it becomes greater than n, that is, in other words, when I becomes 3, you can't take 4 elements from index 3. So here I plus 4, 3 plus 4 is 7, there are no 7 elements, so that is where we stop. So now that we got to know this basic idea, let us increase I one at a time. Now here's basically what we need to do. Now, the first thing is I am taking I as 1. Please note this, guys. I'm taking I as 1 and not 0. The reason I'm not taking it as 0 is because at 0, I am calculating this sum already. Once I calculate the sum of these 4 elements, I store it as a variable sum in my case. So we need one more variable. Let's call it as sum. You guys can start this with 0 initially by taking sum equals 0. That's also possible. You guys can even do that. So let us do the same. So all that we are doing here is in this for loop. Please note this, guys. What we need to do here is, again, this is where your most important logic comes up. So please note this very, very clearly and carefully. And any questions you may have, you can feel free to ask. So here's the thing, guys. We need to calculate sum of these first 4 elements. That is sum of I plus 1, I plus 2 and I plus 3. And we will store the result in sum. Once we do this, when we increase the I value, now I value is 1. I'm just going to move this slightly behind so it is entirely covered here. So now I value becomes 1 greater than what it was earlier. So what you need to calculate now is sum of these. Now here's the thing. You can say sum of 2, 3, 4, 5 is almost equal to sum of 1, 2, 3, 4, except you're subtracting the first value. That is, you're subtracting I minus 1 and you're adding I plus 3. So since we are doing this change in every loop, that is why I wanted to make sure that we begin with 1. So the first thing we're going to do is take just a simple for loop, and you can just say that in this for loop, from I till you reach I plus k, that is the first case. From I till you reach I plus k, calculate the sum and store it in sum. So let's just do the same. For I equals 0, I less than equal to k, or I less than k, I plus plus. Remember guys, k is the number of elements we are supposed to consider in our sub array. If we are considering 4 elements, we're going to go from index 0 to 3. That is 4 elements. 4 is k. So that is why we are going from 0 to k minus 1. From 0 to k minus 1, that is I less than k, we're going to take sum is equal to sum plus p of I. We are adding p of I, whatever is in the array, to sum. Once we do this, you're getting sum of first k elements. So I don't need to store sum as 0 again, and I can start here with 1. So once we start with 1, here's the thing guys, the moment I start with 1, all I need to do here is just, I'll repeat, the moment we start with 1, we just need to have moved 0 here. Let me just move it back. So at 1, I is 1. What we need to do is subtract I minus 1. We need to subtract I minus 1 from sum. And we need to add I plus k minus 1. Remember guys, what is I plus k minus 1? K is 4, 4 minus 1 is 3. That is basically what we need to add. So I don't need to perform two extra additions. That is my sub problem, unique sub problem. I don't need to solve again. So all I need to do is subtract p of I minus 1. Let us do that. So all that I'm going to do here is, again, please note guys, one more thing. Please note this very carefully. Currently, sum is stored with 1 plus 2 plus 3 plus 4. That is 10. If that is the highest sum, I need something else to compare with it. I need another value to compare with it. So I need to store sum of 2, 3, 4, 5 in a different variable. So to store it in a different variable, I'm going to take something else called current sum. So current sum also I'm going to store 10 itself for now. It's the same thing. So what I'm going to do here is, in my current sum value, I'm going to subtract with p of I minus 1. Once we subtract with 1, it's going to become 9. And we add with p of I plus k minus 1. That is, we are adding with 5. It's going to become 14. That is the sum of our current sub array. So once we calculate this, we check if current sum is greater than sum. If current sum is greater than sum we will update it to the value of current sum. This is the basic idea. So let us do the same here. I'm going to take one more value called current sum. So once this entire first k element sum is calculated, current sum will also be equal to the same value. So all that we're going to do here is, current sum is equal to current sum minus p of I minus 1. So here, instead of current sum equals current sum minus p of I minus 1, you can directly write it in short as current sum minus equals p of I minus 1 as well. Both are pretty much the same. That's completely up to you. Once you have subtracted p of I minus 1, we're going to add p of I plus k minus 1. Let us do the same. Current sum is equal to current sum plus p of I plus k minus 1. Since you're subtracting and adding in two different statements, if you want, you can combine them into a single statement here. That is, in a single statement, you're taking current sum, which is 10. You're subtracting p of I minus 1 and you're adding p of I plus k minus 1. Sorry, plus the value 5. So this is again going to come up to 14 itself. So once it is finally updated, let's say to the value 14, all that you need to do here is take this value 14, update it to our final sum value. So we're just going to take and check if current sum greater than sum. We're just going to make sum equals current sum, and this you keep on repeating until I plus k less than equal to sum. Sorry, until I plus k less than equal to n. That is, think about this guys, until I plus k less than equal to n. What's going to be the value here? We know I could be anything. I plus k is 4. I plus 4 less than or equal to 6. So I can maximum be 2. That means we can take these values at maximum. That's it. So this is your entire code. Finally, whatever is the sum, that is basically what you need to print. Let us see whether this works correctly or have we gone wrong somewhere. So let's compile this. And first thing I'm going to do in execution is that it asks how many elements I have to enter. I'll just take 6 as expected, and I'll give the same value 1, 2, 3, 4, 5, and 6. And maximum sub array, I'm going to give it as 4. Now, when you calculate this, when you find the output, is this correct? Think through, guys. Is this correct? It's not correct. There's something going wrong here in this program. When you get current sum and sum equals current sum through this loop, there's something that is slightly wrong with this. I want you guys to think through and figure out. By the time I'll just show this code, think through, guys. I want you guys to take just a minute of time. I'll see if anyone from our chat can get it right for the first time. Let's just try seeing if any one of you can get it perfectly. So remember, you're reading a value n, you're creating an array of n elements, you're reading all the elements, you're reading k, you're going through each first k elements, printing sum. So for your reference, I'll also print here sum is percentage d slash n comma sum. I need you guys to try figuring it out. I know you guys are in live chat. I know that whatever I'm putting out as a video might be received just a few seconds in delay. So I'm going to give you guys one more example here. I'll take the same thing, 1 2 3 4 5 and 6, and I'm going to give 4 as k value. Here you guys can see sum itself is calculated wrong. When the moment you start, sum itself is calculated wrong. The reason, we didn't initialize it to 0 to begin with. That's it. Once you initialize it to 0, I wanted to get at least one of you to say this answer. Unfortunately, we couldn't. Not a problem, no issues. So let us try it now. Let's give 6 elements. I'm going to give 1 2 3 4 5 and 6 as the input and 4 as the range. Now I'm going to get this. So it's supposed to give me sum as 18. Let's see if it is correct. In our case, 3 plus 4 plus 5 plus 6, that is basically 18. So yes, sum is percentage d. We have put it in print inside for loop. You guys can put it outside for loop for you to understand. If you guys do try this by yourselves, you can try understanding this. But in an interview, please don't print this on screen. If you print it on screen, it's always gonna give you an error because you're printing much more than what is supposed to be just the output. This is your maximum sum. What they have asked in the question was maximum average. So all that you need to do here while printing is just print it as float value and take sum divided by 4.0. That's basically it. So once you do it as let's say percentage f slash n comma sum by 4.0, if you run it now, let's say the same 6 elements, 1 2 3 4 5 and 6, and the average is like 4. When you get this value, it divides 18 by 18 by 4, which gives you the result as 4.5. So this is your basic sliding window program. So I have one more question, that is, you took elements in a sorted form. If they are not sorted, also, it works perfectly as it is. There is no problem with it. It works absolutely the same. Think about this. Even if it's not sorted, take this for instance. I'll just remove these elements. I'm going to make this as 1 minus 2 3 minus 12 4 and minus 17. No matter what you take, first 4 elements sum is calculated, then it goes to next 4 elements, then it goes to next 4 elements. So you can take positive, negative values, basically anything over here, and you don't even need to sort it. You don't even need to do n log n times n square times any number of times. Here your for loop basically works. One is k times, another is k minus n minus k times. So the worst time complexity you can get is big O of k plus big O of n minus k, which is basically again big O of n. This only takes n efforts, unlike any sorting algorithm which minimum takes big O of n log n. We can see how this program is faster than the other ones. So I'm just going to copy this code for your reference here and paste it here. Now I'll just show you guys what are the other kind of questions you can possibly expect using this kind of logic. Such sliding window programs are often asked, and if you do it using n square, using bubble sort or something like that, you will always get this time limit exceeded error. So remember, this is some sort of programs that can be asked. It can also be asked something like this. Given there are n students with roll number 1, 2, 3, 4 up to n. Now they're all sitting next to each other. Find out which 3 students who sit next to each other score the least average score. So they're basically stating which 3 members sitting next to each other score the least average score. That means if you have 5 or 7 scores, let's say the scores is 90, 87, 45, 46, 47, and 99. Now the ones who have scored 45, 46, 47, we can easily see have scored the least. Now roll numbers here start from 1, 2, 3, 4, 5, 6. Now all that you need to do in such a program is, one, you need to calculate least sum, whichever is the least sum. So in this case, instead of our logic, that is current sum greater than sum, we just need to change it so that we check current sum lesser than sum. I'm going to point this question, I'm going to write this question, and I'm going to share the same code by solving this so that you guys can try figuring out the same here as well. So give this a thought, guys. In our program here, basically this is what you need to know. Given n students with roll numbers, let's say from 1 to n, are sitting next to each other with their marks, find the 3 students who sit next to each other who have the lowest average marks. Now you don't need to calculate average. When you calculate lowest sum, that's basically lowest average. So I have one question, at least sum for what number of person? Yeah, you can also find out, yeah, least sum for what number of person. Exactly correct. That is exactly what we are supposed to calculate here. So in this case, instead of greater than, all you need to do is find lesser than. When you do lesser than, you're going to find the least sum. But the problem is, in the question they have asked, print the 3 roll numbers of the students in the below order. That is, let's take an order like this, 1 and 2, 3, 4, 5, 6. Let's say 3, 4, and 5 have the least sum. So we need to print 3, 4, 5 as the output. So again, I'll repeat. Input here is, let's say the first input is something like 6, and the 6 scores are something like 90, 89, 88, 45, 46, 47, and 99. And once this is done, they may give find lowest average of n numbers, which means you have to take k as input as well. But in this case, they're not asking k as input, they're just asking 3 people who are sitting next to each other. And in that case, since these 3 are getting the least sum, I need to find indices of it. Index here is 1, 0, 1, 2, 3, 4, 5. Along with sum, you need one more variable which is going to store starting index. Once you find starting index, if you want to print the 3 roll numbers who have the least marks, you just have to add this starting index by 1 and print 3 consecutive values. That's basically it. So all we need to do in our case is just take one more integer. Let's just take it as start index. So whenever initially start index will be 0, whenever sum is, sorry, current sum is not greater than, I mean lesser than, it should be lesser than, because we are supposed to take the least value. Whenever current sum is lesser than sum, we're going to take sum is equal to current sum, and whatever is the least value you get at that point of time, since yes, they have to be sitting next to each other, that I have received they have to be sitting next to each other. Only then you're supposed to find out. This is the kind of question you may expect. If you expect such questions, this is basically how you may solve it. So going ahead with this, let us try figuring it out. So all we need to do is, once we get the starting index, just add 1 and print from there. Don't print sum or anything, just print three values, percentage d and percentage d. And here all you need to do is print this start index, which will be I. Remember, start index is I, which keeps on increasing. You just have to print I plus 1, I plus 2, I plus 3. That's basically it. So let us see and check if this works. We'll compile it, run it. I'm going to give 6 students and I'm going to give the same values: 90, 89, 88, and sorry, not 88, 45, 46, 47, and 89. So 3, 4, and 5 is supposed to be our output. Okay, I'll give it as 3, but it gives it as 5, 6, 7. Remember, we're supposed to do start index. This is where it is stored, not I plus 1, I plus 2, I plus 3. We're just supposed to do start index plus 1, start index plus 2, start index plus 3. That's it. I also have a statement that it is such a tough question. Yes, they're giving you so much salary because you can solve such tough questions. The basic idea when it comes to TCS Digital is that they assume that you know programming well so that you can solve these. Once you join the company, once this is solved, you're going to go through training further on. So until tomorrow, as much as you can, my suggestion is go through as many of such programs as possible so that you can try solving these. So let us try running this now with the same exact input, that is 90, 89, and then 45, 46, 47, and 99. Here again, sorry guys, I should be using the number of elements first. So 90, 89, 45, 46, 47, and 98. Once this is done, let me give window as 3. Now it gives me third, fourth, and fifth people with the roll number, not 1, not 2, but 3, 4, 5, who are sitting next to each other, are getting the least scores, least average. But if output is supposed to be 3, 4, 5, you have to print it with commas only. So your output should be something like this. This is the basic idea. So this is one more example for you on sliding window program. So is this now at least easy, guys? Let me know through a comment. I'll just give you guys a minute of time. I'll take any questions that you guys may have on sliding window programs. I'll give you guys a minute of time. Go through this. Any questions you guys may have, please ask. I will answer the same. So I have a question. That is, first I will find the smallest number in an array and simply add consecutive sum of 3 and compare them whose 3 are basically least. Yes, see here, your idea is okay, one of you have just stated this. I'll tell you guys why this is not dynamic program, the statement that I just received. Yes, you can do this. Take first 3 elements, calculate sum, and then take next 3 elements. Let's say take the next 3 elements, calculate sum, check if this sum is lesser than this. But the problem is, when you're calculating sum for the second time, you're performing 87 plus 45 again. You're performing it for the second time, when in the question they give larger k values and a very huge n value. When n value is something like 100 and k values are like 6 or 7 or something like that, after calculating first 6 values, you need to calculate sum of second 6 values. Instead of calculating all 6 values, you can just subtract first, add the last value basically, and just work through it. That is the basic idea of this. I hope that makes it simple and easy to solve now. So from this, I'll repeat, if there are any questions in sliding window problems, do ask, guys. I'll wait for a minute to see if there are any more questions. If there are no questions in sliding window, I will go ahead and start with a different problem, that is knapsack problem. That is also a very common question that is often asked. So one question, what exactly is a sliding window problem? Basically, see, in this, you are calculating sum of first four values. After that, you are calculating sum of next four values. After that, you are calculating sum of next four values. This is just moving in the same order. You're just sliding this window of numbers one at a time. That is basically called sliding window problem. That's it. So I'll also specify where else you can expect such questions. What other kind of questions you can expect through this. I have one question. By the time, can we expect these type of questions in other interviews also? You may, you never know, you just may. You can't guarantee what exact kind of questions will be asked in what exact interview, so you may just expect anything basically. So going ahead from here, I have one more question. Is this a memorization problem or a tabulation problem? See, when you talk about memorization and tabulation problem, the basic difference, I'll point out again, in memorization, you start taking sub problems. I'll just point out to this again, whatever I've shared, so that it becomes easy for you to understand. In memorization, you do a top down approach. You calculate the bigger solution, you divide it into smaller part, and you start solving each smaller solution. In tabulation, you start solving each small part and combine them to find a bigger one. So this basically is where you're dividing a bigger problem into smaller parts. This is memorization and not tabulation. In tabulation, you need to create generally a table of data from the smallest value to larger value, and using that final larger value, you start to find out what could basically be the output. So now that this is clear, I see that I have one more question, that is, how can we find a particular problem is from dynamic programming? See, it's pretty simple. Not every problem in is going to be dynamic problem, dynamic programming problem. If you want to find out whether a question is dynamic programming or not, think, if the question has multiple things to solve, if the question can be divided into sub problems, and are you calculating something in one sub problem which is also calculated in another sub problem, then yes, it is a dynamic programming problem. So just remember this, in one sub problem, if you're calculating something which you're calculating again in another sub problem, that is a dynamic programming problem. That's it. So this logic is similar to all sliding window problems, but not same. So I'm going to give you guys a couple of other kind of questions as possible questions you can expect. Think of this. We tried maximum average. We tried this sort of problem. You can expect such a thing as minimum sum sub array and so on. This can also be asked with strings. Here's how you can expect a question on this when it comes down to strings. To do this, we basically use a slightly different logic. We also call it a staircase logic. Think to observe this, guys. Think about a string. So let's say I take a string like A, B, C, C, A, B, A, C, B, or something like that. You need to find what is the length of the maximum, what is the maximum length of a substring, what is the maximum length of a substring which, I'll repeat, which has no repeated characters. If you think about this, first you're going to start with A. So from A, then you're going to take B, nothing is repeated. Okay, after B, you're going to take C, nothing is repeated in all of this. After this, you're going to take C, but this C is already repeated. So you can say maximum length so far found is 3. After maximum length found is 3. Once this is done, then go from here. This is already repeated here. Since it is already repeated here, wherever it is repeated, skip from there to the next character. So I'm starting with C, A, B, none of them are repeated. When you go here, A is already repeated. So again, you're finding length as 3 itself. Since it is getting repeated at here, go to the next character of this. From here, start searching again, B, A, C. Again, it's 3 because B is again repeated here. So this is how you can basically keep going and searching the maximum substring length. Now to solve this, your logic here is not memorization. Your logic here will be tabulation. That is, for a substring, when you keep on going from here to here, you're going to start searching whether, when you start with the first character, is second character here? No. Then go on to the next character. Is third character here in this previous two characters? No. Then you go on to the fourth character. Is fourth character here in any of these? Yes. When you find a character in any of the previous ones, you need to remember the starting index where you started from and the final index where you're ending from. So since one of them is already available previously, this cannot be maximum length. This minus 1 is maximum length. So maximum length will be j minus I. You're gonna get this. So if it is 0, 1, 2, 3, 3 minus 0, you basically get 3. So that is how you find it. And to solve this, you need a copy of all these three values. You need to keep searching whether C is present in any of these. You need to use a for loop to do that. The moment you do that, and once you're done, you don't have to start from B, C, C. You don't need to immediately start with the next one because it is already solved. Because this C is found here. Since it is found here, directly wherever it is found, go from there itself. There's no point in going ahead. So wherever that variable was found before, wherever it is found before, go from its next character. So once you start from here, C, A, B, and A, since A is repeated here, you don't need to start searching from A here again because you know it's going to be repeated anyway. Instead, start from the next character ahead. This is the basic idea that is also used for a variation of this, which can also be solved in sliding window problem using tabulation. In tabulation, you need to search with the previous elements. If you guys want, you can store the previous elements in a set if it is in Java to make the code easier. Instead of comparing through each character before, you can store it in a set. Or in C++, you can store it in a vector, which makes it faster because vector are dynamic arrays. So I'm not going to go into this program entirely, but I'm just going to basically go through this in short. I'm just explaining this. I have one more question. Isn't it brute force? See, brute force is when you basically start every character in that same order, every character you're going through. When it comes down to sliding window, let's say once ABC is checked, since C is here, you're now directly going for ahead of C. You're not checking C again, you're going from here. Here, once A is found, you're going ahead of A directly. You're not going from C. In brute force, you don't check any logic. You're checking ABC, nothing is repeated. Then you're checking BCC, nothing is repeated. Then you're checking CC. There's no point in checking that. Then going ahead and so on. So I have one question. In this set, there is no repetition. Not the point. In set, you can store A, B, and C at the start. And when you go for the next value, you can directly compare whether C is there or not. You can directly use search function within a set to check if it is there or not when it comes to Java. Unlike in C, if you want to check if it's there in the previous values, you need to check in every index. That is the basic idea. That is how when you store it in a table, you can directly search if it is there in that table or not. That is the basic idea. But I hope you guys get a basic idea of how these problems are also solved. Now, going ahead from here, let us now move on to a very different kind of problem that is often expected. That is very often expected. Think of this, guys. This is your question. John has found a treasure cave. John cannot take all the treasure back. Once he takes the treasure, I'll just put this in the next line so you guys can easily read the whole program. Once he takes the treasure cave closes automatically. Once he takes the treasure and leaves, I'll point it out, and leaves, the treasure cave closes automatically. Now, John can carry only X kilograms. John can carry only X kilograms. The treasure has N distinct items. The treasure in the cave has N distinct things, whatever it could be. And here's basically what it is. These N distinct items will have, these N distinct treasures will have their own price and weight. You need to figure out which are the possible things that John can take, or what is the maximum price value of treasure that John can take. Think of this, guys. I'm just going to give you guys one simple clue to solve this. Let's take, for instance, the treasure room has 5 treasures or 4 treasures or something like that. I'm just going to take a very simple case for our understanding to begin with this. Let's say the treasure room has only 3 treasures, and these are the 3 treasures. So the 3 treasures have a price or a value, something like this, and they have a certain weight. And John can carry a maximum weight of, let's say, 50 kgs. It doesn't matter how many things he's carrying. The point is he can only carry 50 kgs at maximum. Now, in this case, let us try solving this. Let's say the first treasure item value is, let's say, 60. Second treasure item value is, say, 100. Third treasure item value is, say, 120. And the weight of these are, let's say, 10, 20, and 30. Now, I'm just going to ask you guys, what is the maximum value that John can carry? What are we going to do? We're going to try to figure out permutations. This problem is also called 0/1 knapsack problem. 0/1 is specifically pointed because you can either make a treasure value, whatever this element is, as 0, that means you're not carrying it, or 1 means you are carrying it. There's no in between. Every element is either being carried or not carried. So in this case, since John can either carry or not carry, we need to start figuring out how to solve this. Now there are multiple cases. He can carry only the first one, he possibly can't carry all of them because the weight of everything is more. He possibly can carry only one. He can carry only the middle one. He can carry the middle one and the last one, and so on. So if you keep calculating all these permutations for 3 of them, for 3 treasure items, you get 2 cube permutations, 2 cube possible values. That is going to be 8. So the worst time complexity here is 2 to the power of n. So for every value n increases, your worst time complexity increases exponentially. Note this, guys. Every time n increases, let's say this is n, this is your big O, that is 2 power n. Every time n increases, this exponentially increases the time. Now we don't want the time to increase so much. We don't want to spend so much time over here. So one of you have also asked, is this knapsack problem? Exactly, yes. This is same. This is basically your knapsack problem, which can be asked in many ways. So let us try how to solve this. And I'll repeat, this is a very common question and has been asked in the previous year's questions as well when it comes down to this. So let us try figuring out how exactly can we solve this. Now we learned, if we don't use dynamic programming, our worst case complexity or our worst time complexity here is 2 to the power of n, which is a lot of time. And as a compiler, it won't accept such huge time. So we need to find something smaller, something smarter, a way which can solve this. So right now, if you calculate it, the maximum he can carry is either 10 and 20, which only gives 160, 20 and 30 only, which gives 220, or 30 and 10 only, then he can't carry 20. If you try to calculate all permutations, the best possible solution is carrying the object with weight 20 and 30, which is going to be exactly 50 kgs. That is going to give him a price value of 220. That is basically what we are supposed to print. So here, to do this, let us try to figure out how first, and then we will see what could be the maximum time complexity that we may reach. So first we learned, without dynamic programming, how much time does it take. Now let's try to do this with dynamic programming. Now for us to solve with dynamic programming, I'm going to take a slightly larger example. I'm going to take a slightly bigger example so we can understand the entire logic and we can solve any sort of code when it comes down to this. So think about this, guys. Let's say we have 4 elements or 4 treasure items, and I'll also state in what different ways can this possibly asked. This can be asked, a vehicle is traveling and it can only store a maximum of something. So what is the maximum it can store? You can expect multiple ways that this knapsack problem can be asked. So let's say there are 4 elements and their price and their weight are given here. Let's say price of first element is 1, second element is 2, third element is 5, and fourth element is, I'll just take something like 6. Let's say weight of these elements are 2, 3, 5, or let's take it as 2, 3, 4, and 5. So this is the price and weight of basically each of the element that we're going to take. Now the question that comes up here is, a person can only have a maximum capacity. I'll repeat this, maximum capacity is 8 kgs. Let's say 8 is the maximum capacity. If 8 is the maximum capacity, we need to figure out how many of these 4 values can he carry so that his price is highest. And we should not do it the previous way. That is basically just saying that it's a recursion which takes the same steps again and again. Now, I had gotten a question earlier from one of you. How do we find that a particular problem is dynamic programming problem or not? Think about this. In this case, students, please hold on for just 1 minute. Alright, so going ahead, students, back to this. In this case, assume you're calculating whether he can carry all these 3 without this. And then you're calculating whether he can carry all 4 of this. When you're calculating whether he can carry all 4 of this, are you not incorporating the solution of previous sub problem? In previous sub problem, you're saying that he's going to carry these 3, which means you're adding the price of these 3, you're adding the weight of these 3. In the next one, when you're saying he's carrying all 4, are you not adding the price and the weight of the final 3 values again? Yes. So that means we are repeating the solution. unique solution of a sub problem in another sub problem. So this is basically, we need to start figuring out how we can make this dynamic. So that is where we're going to use the concept of knapsack problem using dynamic programming. So students, please wait for just 1 minute. So going over here, let's try this out. So the first thing we need to do is create a table. Now I want you guys to observe this very, very clearly, because this is the whole logic by which we solve a knapsack problem. So guys, please make sure you observe this very clearly, and any question that you may have, please go on and ask. Now the first thing you need to do is figure out, since maximum capacity is 8, you need to create an array which can take 0, 1, 2, 3, 4, 5, 6, 7 up to 8. Because since maximum capacity is 8, we need to calculate every permutation. That is, which case only 0 is the maximum capacity, in which case only 1 will be the maximum capacity. We need to figure out all of these in order to figure out 8th capacity. We are creating a table here. So this is basically tabulation method. This is not memorization method. So we are going from a bottom up approach. We're going to take from here all the way until we reach 8. So let's try figuring it out. So think about this, guys. This, I'll repeat, columns, this represents weight. Remember, this represents weight, and for weight you have a maximum capacity which we have specified here. Now as rows, we will specify the number of elements. Number of elements can be 0, or number of elements can be 1, 2, 3, or at maximum John, let's say, can carry all 4 elements. Now here's the basic thing. I'll just point out lines here so that we can just easily understand that this looks like a table, so that we don't get confused with any number overlapping between. So I'm just going to draw these lines. So we have our condition that user can may not be able to carry any, because if his capacity is just something like 1, let's say if its capacity is just 1, there's no weight which is 1, so he basically cannot carry everything, so his carrying capacity will be 0. So let's observe this, guys, and I want you guys to observe this very, very clearly, because this is the most important logic. I'll repeat again, the most important logic that you need to know in order to solve knapsack problems. So here when you solve this, let's start with the very basics. This here is price, sorry, this here is number of elements, and this here is weight. So I'll tell you guys why that we are starting with 0. So when the person is carrying 0 elements, what will be the weight of it? What will be, whether maximum capacity is 0, maximum weight is 1, 2, 3, 4, maximum capacity of the bag can be anything. When the person is carrying 0 weight, the capacity carried is just 0. Capacity filled is always 0. Similarly, when the weight of the bag is 0, I'll repeat, when the weight of the bag is 0, he can't carry anything. He can't carry anything. So everywhere I'm writing basically 0. I hope this is clear. Please let me know, guys, to everyone through live chat. You guys can let me know any confusions with this. I'll try to explain it again if required. So the basic idea here is, when the number of elements stored are 0, in that case, no element, the weight stored is basically 0, or the price is basically 0. When the capacity of the bag is 0, you can't store anything in it, so price is also 0. I'll repeat this once again. For those who are a little confused, all that we are doing here is for how many number of elements, based on how many weight, we are entering here, entering everywhere here, what will be the price that we can store, because we need to know maximum price. That's our idea. So I hope this first basic point is clear to everyone. When weight is 0, no elements can be stored. When number of elements stored is 0, price is also entirely 0. Now let's go for the first thing. Now remember guys, remember very clearly, our idea was to make it dynamic programming so that we don't have to repeat. In other words, we don't have to repeat the same steps again and again while solving. So first, let us figure out if the first element, if one element is entered, if basically one element is entered, what could be the value? Now here's the thing guys, observe this. This one refers to the first element. This two refers to first and second element together. This is something that is very crucial for us to understand. One represents first element. That means you're only storing first element. Once we get to know what will be the price only when I store first element, I can start figuring out what is the price when I store first two elements. Then once I figure out what will be the maximum price when I store first two elements, I will calculate what will be the maximum price when I store first three elements. Once I've done that, I'll start calculating what will be the price when I store first four elements together. Now, remember, capacity is 8 at maximum. We are not going to go more than that. So, from here, let's begin with the basics over here. Now, the first thing we're going to start with here is for the element here. When I take only, sorry guys, white color, when I take only the first element, remember, first element price is 1 and weight is 2. Remember this clearly guys, price is 1 and weight is 2. So when the first element price is 1 and weight is 2, can I store it in a capacity, in a bag with a capacity of just 1? I basically cannot. I just can't. So I say I can't store it because first element cannot be stored in a bag of capacity 1. Remember, I'll repeat again. This column represents capacity, weight, and these rows represent elements we are choosing. So when I take first element, which basically weighs 2, I can't store it in a capacity of bag, capacity 1. Now if I do the same thing, first element, can I store it in a bag with capacity of 2? Yes, I can. So I can store this first element with a bag capacity of 2, and the price I get from this, the price I get from this element, that is the first element which I can store in capacity 2 because its weight is 2, is 1. So I will say price that I gain is 1 here. So once we have done this, the next thing is, remember, I'm only taking one element. Number of elements taken is basically 1. So since number of elements taken is basically 1 here, and we keep on moving, since number of elements taken is just the first element, no matter how much is the capacity, since we are only storing one element, that is the first element, only one weight or 1 kg will be filled. The rest will not be filled at all. That's the basic idea. So from here, let us go on. Now students, please wait for just one moment. Please hold. Alright, so going back here, I hope this makes the first part very clear. So the first part is just that we are starting with the first value from left to right, and since the first value, which has weight 2, cannot be stored in a capacity of 1, we can't store it. From weight 2 we can store the first value. Done. Now let's go for first two values. Now the reason we are going for first two values now is that it starts, now that we know already what will be the weight when we store first values, we are going to be able to understand how to store first two values now very easily. So we can use this previous data that we have just used, and continuously store over there. We don't have to use the same again and again. So all that we're going to do here is, if two elements are stored, basically it's repetition of the previous value. You don't have to calculate again. When two elements are stored, observe here guys, when two elements are stored at the start, you're just figuring out weight is 2, I can't store anything, it's 0. Weight is 1 because maximum capacity is 1. Here when weight is maximum capacity is 2, I have weight as 2 and 3. So weight as 2 has a price 1, which is the only thing that can be stored here. So I'll just state that the price is the price is 1 because weight is 2 and the price is basically 1, which we can store here. So once this is done, when we go for, let's say, maximum weight that can be stored as 3, now we have in our two elements two options, either one with weight 2 or the one with weight 3. If you take the one with weight 2, the price is only 1. If you take the one with weight 3, the price is 2. So the one with weight 3 is better. So we'll state that the price that can be stored here is 2. And if you take 4 weight, both cannot be placed together, price will be, let's not fill this, until you reach combination of both weights, that is 2 and 3 together 5. Until you reach combination of both weights 5, you can only store this 1, so it's gonna be continuing as 2 only. When we reach the combination of both these as 5, from there till the end, since you can store both from minimum capacity as 5, you can add price of both, that is 1 plus 2, basically 3 from here. So this is if we are storing only first two elements. Note this very clearly guys. If you observe here, the first part of it is same in second part as well. Something here is repeated. I'll just try to highlight this for your reference. Here it is repeated. The rest are different because from here you can store the higher sized value as well, but until then it's the same. Now let's go for three elements. When we go for three elements, again remember, until you start storing first two elements, mostly it's going to be the same. The reason it's going to be the same is because we have put weight in ascending order. The reason I've put weight in ascending order is that we take a simple example and understand this easily and start writing the code of this as quickly as possible. So here, when we have three elements, when the capacity is just 1, of course, I can't store anything because all the weight are more than 1. When the capacity is 2, again, when capacity is 2, I can only store this one thing, which basically has 1. So I'm storing just 1. Sorry guys, here it's supposed to be 0 because when capacity is 0, I can't store anything. When capacity is 2, I can store the item which has weight of 2 but price as 1. Since its price is 1, I'm going to state that price is 1. After this, let's go for 3. When weight is 3, remember here we are talking about 3 elements, that is we are going to consider first 3 elements. In the first 3 elements, we're going to check here, can I store anything new with just 3? Is the weight here is 3 or lesser than 3? Observe this very clearly guys. The weight here is 4. So until you reach 4, there will be no changes. I will repeat. The current element, third element, weight is 4. So I can't store third element until I reach weight as 4. So until I reach weight 4, I have to copy the same thing as the previous row. So I'll repeat, until we reach this weight, I'm going to copy the same thing as previous. Once I reach this weight, I'm going to change my logic. Once I reach weight 4, I need to check whether storing just 4 is of higher price or the previous value was of higher price. Just 4 being stored gives me a value of 5, which is higher price than the previous value 2. Since it is greater, I'm going to store just this third value whose weight is 4 and it stores with a value 5. Now, to many of you guys, it may feel like knapsack problem is slightly confusing. It's slightly difficult. Do not worry. I'm going to explain the logic with the code after this so that you can find it much easier. So not to worry if it's slightly difficult right now. By the time we go for next line, once you see the code, you will get to see that it's damn easy. So once we go on to 5, we again need to realize maximum weight is 5. What can we store here? I can store combination of 2 and 3. If I store combination of 2 and 3 for 5 weight, I'm going to get price 3. If I only store this, I'm going to get price 5. So I'm supposed to store only this, price 5. Then take, let's say, 6. When I take 6, 4 is the weight here, 2 is the weight here. I can take a combination of these two, that is 5 plus 1, that is maximum price I can store here is 6. So I'm going to make sure this is basically 6. So once this is done, let's now go for weight 7. In weight 7, I can store all these 3. Remember guys, weight of 3 elements. Weight of 3 elements is 2 plus 3 plus 4. So 2 plus 3 plus 4 weight that we basically get here is 1 plus 2 plus 5. That is the price we get, because weight is 7. For that 7, I need to take price of all 3 together. So 1 plus 2 plus 5, I'm going to get price as 7. So even if the capacity increases now, it's going to remain the same. Even if the capacity increases, since we have selected all elements, we can't increase anymore because we are supposed to select only 3. So our price is going to remain the same as 7. So when we go for the next one, you guys now have a better idea of how to select this. Here's the formula. I'll write the formula for this so that you guys can easily understand. Now comes the ability to understand this code. So observe this very clearly, guys. Your code is in this table. You just need to calculate in every row maximum of 2 values. Those 2 values are either it should be previous value. If the previous value is maximum, you're copying that. So that previous value is, if this is I and this is W, instead of J, I'll call this as W because W stands for weight. So in this I comma W, remember I is the row number, W is the column number. If this is where we are, if I need to find what value can be stored here, I need to either copy the previous one or I need to check some other formula. So this is the basic formula. I'll write the formula first, then I'll explain how it works. Your basic idea is table of, or just I'll call it as T of I comma W. I'll state I equals row number that indicates number of elements. Remember, 0 means 0 elements, 1 means 1 element, 2 means 2 elements. Similarly, W equals column number which indicates capacity, and T of I comma W indicates price for I elements and W capacity. Remember, if I want to carry 3 elements and my capacity is 5, this is the maximum value I'm going to get. If I'm supposed to carry 2 elements and my capacity is 8, this is the maximum value I'm going to get. Something like this. This is basically how we start to figure out. So let's try to figure out our idea. Our idea is that we only got to know maximum capacity. We are not getting to know how many elements are we need to take at maximum. The idea is maximum capacity. So in maximum capacity, we need to do all these permutations. So here, in this case, what I need to calculate in T of I comma W is maximum of two values. The two values here is, observe this very clearly guys, the first value is the previous value. If I want to calculate I comma W, I need to calculate I minus 1 comma W. If this is greater than the other value, I'm supposed to take this itself. So the first value I'm going to take is T of I minus 1, row minus 1, comma, same column. So the first value I'm going to take here is maximum of either T of I minus 1 comma W, or the other value that we're going to take is T of I minus 1 comma W minus W of I, this whole value. I'll repeat, this entire value. I'm just going to put these in brackets so that it's not confusing. Once this entire value is calculated, I need to add it with price of I. This is your entire formula. If you know this, you can calculate any problem with Knapsack. Any Knapsack problem can be calculated with just this one formula. Let's try figuring out this formula, guys. Since we have a limited space on screen where I have to try calculating this, I'm just going to try calculating this for you guys separately over here. Please observe. I currently is 4. W currently is 1. So T of 4 comma 1. The first thing I'm going to do is T of 4 comma 1. This is supposed to be 7. I'll repeat. I'll write this here. T of 4 comma 1. How do I calculate this? This should be maximum of, first, T of 4 minus 1 comma 1. Remember, I is 4, W is 1. So I minus 1 is 4 minus 1. That is T of 3 comma 1. This is the first value, or second value we need to calculate this. Let us do that again later on. But first calculate what is T of 3 comma 1. T of 3 comma 1 is 0. So I'm going to make this as 0. After making it as 0, the next thing I need to calculate this. Let us take this whole formula, try to convert it here. So first thing here is T of, first thing I'm going to do is again I minus 1. I is 4. 4 minus 1 I'm going to directly take as 3. And then I need to calculate W minus W of I. W is 1. I'm going to take it as 1 minus W of I. So what is weight of I, guys? Weight of product I. So currently I is 4. What is weight of product number 4? Weight of product number 4 is 5. Since weight of product 4 is 5, I'm going to take 1 minus 5. That will give me 3 comma minus 4. Now there's no such thing called 3 comma minus 4. So we are going to cancel this out and we're going to directly store it as 0. That's the basic idea. So what happens here is the previous value, previous row itself is stored until this becomes 0. And when this becomes 0 is W minus W of I until it becomes 0, because that is the minimum value 3 of 0 we can get. So until W minus W of I becomes 0, I need to keep on repeating I need to copy the same steps as before. So let us directly calculate what is this W minus W of I. Now W we know is second column, third column, fourth column, fifth column. We need to keep on going. So weight of this product is 5. Since weight of this product is 5, W minus W of I should be 5 minus 5. Weight of the product is 5 until we reach column 5. It won't get the second maximum part. It will only take the first maximum part, because in second, when you go for column 2, 2 minus 5, you can't access. When you go for column 3, you can't access that index. When you go for column 4 also, you can't access index 4 minus 5. But when you go for index 5, you can access 5 minus 5 index 0. So for that reason, until you reach index 5, just keep repeating the same as whatever was earlier on. Whatever was previously, repeat the same thing. I'll explain this with one more example for your reference. Think about this. I want to calculate T of 4 comma 2. Row number is 4, column number is 2. So to calculate T of 4 comma 2, remember I equals 4 and W equals 2. All that we're going to do is copy the same formula again, paste it here. The first thing we are doing is T of I minus 1 comma W. I is 4, W is 2. What is I minus 1? 3. 3 comma W is 2. 3 comma 2 is its previous value, that is 1. So we get to know 3 comma 2 is 1. So I'm just going to replace it here as 1. After that, once I go for the second part, I minus 1 is 4 minus 1, which is 3. Then W minus W of I. W we know is 2. 2 minus weight of current element. Weight of fourth element is 5. So until you reach weight 5, it will always be negative value. So this won't get accepted at all. So 1 is going to be taken. This is the idea. I hope this is clear to everyone. So because of this, until you reach W minus W of I as 5 minus 5, until you reach column number 5, it's going to take the same value as previous value. From here, our logic changes. I hope this is clear to everyone. This is the basic formula. If you know this one single line formula, you can calculate or you can solve any of the knapsack problems. So I hope this now is clear. I hope everyone are able to understand this. Now let's go for the next part. Now we are here in column number 5. Now I is 4 and W is 5. So let's calculate what is T of I comma W here. So when you calculate I comma W, where W is 5, let's take the same formula again, copy it here. Now I is 4, W is 5. Let's try figuring it out. First, T of I minus 1 comma W. I minus 1 here is 4 minus 1, which is 3, and W is 5. I'll take the same as T of 3 comma 5. We'll take the value. T of 3 comma 5 is 5, as we noted here. So we'll take 5 here for this. Now let's go for the second part of formula, which works. Now once you understand this, your whole program becomes so simple and easy. Now T of again I minus 1. The value of I minus 1 here is, as we know, I is 4, 4 minus 1 gives us 3. Once we get 3, again guys, sorry, there's one extra bracket here. There's no need of this extra bracket. I'll remove this. So once we calculate row index 3, we need to calculate column index, which is W minus W of 5. We have already calculated this. W is 5 and weight of fifth element, weight of fourth element. Remember, I is 4. Weight of ith element, which is fourth element, is also 5. Once you get the weight of fourth element, which is also 5, calculate 5 minus 5. It's going to give you 0. This is T of 3 comma 0. What is 3 comma 0? You're getting this particular value, that is 0. So that is basically what we're going to take as 0 here. That 0 should be added to price of I. Price of ith element, since we are I value is 4, fourth element is this. Price of fourth element comes up as 6. So since price of fourth element is 6, I'm going to add it as 0 plus 6. Now which is greater, 5 or 6? Of course 6. So since 6 is greater, when the weight is 5, instead of all these three elements together, instead of weight is 5, when weight is 5, instead of these two elements together, 2 and 3, which gives us weight only as 3, we're going to use this, which gives us weight as 6. That is the basic idea why it comes up as 6 here. So all we need to do is apply the same formula 3 more times. Now since we are learning this formula for the first time, let us quickly apply this. Now I'm going to calculate 4 comma 6. Let us do this as quickly as possible. So when we have T of 4 comma 6, again same formula, same thing. First calculate T of 3 comma 6. Take the previous value. T of 3 comma 6 is 6. So let us take this first value as 6. 6 followed by the next thing, T of I minus 1 comma W minus W of I plus P of I. So I minus 1, again we know it's common, it is 3. and W here is basically weight, which we have figured out already, which is 6, because for each column increment weight, this is the basic W value. So that is going to be again 6 minus what is the weight of our fourth value. We already know that it is 5. We'll calculate 6 minus 5. That gives us 1. So we need to calculate T of 3 comma 1. T of 3 comma 1 is this, which is also 0. So we're going to take 0 plus again P of I. Price of this ith element, we know it is 6. Since we know it is 6, we'll put it up as 6 directly. So both basically are giving us the same value. It doesn't matter. So we're just going to take it up as 6 itself. Now comes the last two part. Let's try to do this quickly. Now column again increases to one more. We'll try to do these last two as quickly as possible, guys. So please observe, I'm going to go through this formula very quickly because I'm going to start with the code of this program right away. So T of 4 comma 7, I hope it is very easy now. It's just T of 3 comma 7, just take its previous value. T of 3 comma 7 is 7. Once you take that 7 as its previous value, then go for T of I minus 1, which is again 3 comma W minus W of I. W is 7th column minus W of I. We know weight of ith value, that is 5, which is always common we're going to have. So 7 minus 5, we're going to again get, instead of 3 of 1, now you're going to get 3 of 2. Then for the last one, you're going to get 3 of 3. So now you're going to get 3 of 2. Sorry, T of 3 comma 2. T of 3 comma 2 is going to give you the value 1, and that 1 you need to add it with price here. When you add that 1 with price, it's basically again 6. So both are same. There's no difference. Just print 7 as it is. Now when you go for the last one, W is 8. We're going to calculate this T of last one, that is 4 comma 8. We know the first one, the first value is basically its previous value. So let's write it as it is, 7. And the next value we know is T of 3 comma 2. Sorry, T of 3 comma 3. Remember guys, I minus 1 is 3, W is 8, 8 minus weight of I. Weight of this ith object is, we know, 5. So 8 minus 5 gives us 3. So let's calculate T of 3 comma 3, which is 2. Once we get this 2 value here, we need to add it with the price of I, which is 6. Now when we calculate this, 2 plus 6 is greater than 7. Now we're going to take this value and store here. So we don't need to calculate the previous value again. That is why we are using this max function. This is basically the simple idea to solve your knapsack problem. So once this is done, you can get to see for a capacity 8, the maximum price you can get is 8. For capacity 7, maximum price you're going to get is 7. For capacity 6, maximum price you're going to get is 6. So you need to calculate this table wise for each number of objects by increasing capacity until you go with the maximum number of objects. What could be maximum capacity? So maximum capacity here comes up 8. This is the logic and this is the formula that we're going to use. So now that we are clear with this entire logic and what formula to use again, do you guys need me to take one more example by any chance, or shall we go for the code? If you guys want to try it, you guys can take a simpler example. I'll just give you one example. I'm not going to solve it. I'll just give you guys this simple example. You guys can try it out. Think of the price and weight. Let's say the price here is assume 10, 15 and 40. Let's say the weight here, let's assume it is 1, 2, 3. So let's say maximum capacity is 6. Since maximum capacity is 6, you need to create a table with 6 columns. Remember, maximum capacity is 6. You need to create a table with 6 columns. That is 0, 1, 2, 3, 4, 5, 6. Sorry, 7 columns. And since number of elements are 3, you need to create number of rows as 3 plus 1. That is when you can't carry any element, when you can carry just one element, when you can carry just 2 elements, and when you can carry all 3 elements. So this is the basic idea. And once we do this, our initial value for zeros will all become 0, because when the carrying capacity is 0, you can't carry anything. when the number of elements you're carrying is 0, your whole price is again 0. You basically can't carry anything. Is this clear, guys? I hope this makes it a little clear. I hope this makes it easy to understand as well for us. Now, from this, our next idea is where we start to store from here. So now that we are clear till here, let's implement only till here in our code. So again, I'm going to remove everything we had written in the previous program. I hope I've copied this for your reference earlier. Yes, we have. So let's remove all of this. Since it is int main, I'm just going to use return 0. So I'm going to give you guys half the program. That is a little assignment. I'm going to ask you guys to try it out as well. Just a little bit of assignment I'm going to ask you guys to do. So one thing I do need is a function which calculates maximum. So I'm going to create a maximum function with two variables, int a comma int b. It's going to return maximum of the two values. So I'll just write something like return if a greater than b, return a, else return b. You can just write in one single ternary operation, or you can actually write conditions if you want. That is, if a greater than b, return a, else return b, or you can skip else and just state return b. That's completely up to you, but I'm just going to keep it at this. So the first thing we need to do here is read the number of elements. Once we read number of elements, we need to create one array which is going to read price of the elements, and another array which is going to read weight of these elements. So let's start this. Let's take int, let's say n, which is supposed to be number of elements. Let's just read percentage d comma ampersand n. That is the number of elements. Assuming in question they will say that input is first n, which is number of elements, then the input is p, which is price of each element, then the input is, let's say for instance w, which is weight of each element. So if they specify input in this order, you have to read inputs in the same order, guys. Please always remember, don't read inputs in any other way. I have one more question. Can we use math.max in Java? Yes, you can do that. In Java, you have an inbuilt function called math.max, which you can use. Now, assuming we have students from different branches who may not be able to use such functions, particularly because they may not know Java, and it's difficult to learn in one day because tomorrow you have interview, possibly many of you. That is the reason why we are taking up in C. I hope that is clear. So once these are entered, that is number of elements, price of each element, weight of each element, then one more value will be entered, which is capacity of the bag or something like this. So let us take this capacity of the bag as well. So I'm gonna have to read two values, that is n and capacity of the bag, or I'll just call it as weight of the bag. Apart from this, I'm gonna need two arrays, that is one array called price and another array called weight. So once we read the n number of elements, the next thing I'm gonna have to read price of each element. So let's take a for loop for I equals 0, I less than n, I plus plus. I'm gonna perform scanf percentage d comma ampersand price of I. We're gonna store within price array. But before that, we need to create an array which stores n elements for price. So as earlier, we're just gonna do price equals malloc of size of int multiplied by n. So it's gonna create so much memory allocated to a program, and it's gonna return starting address. And since we need to convert it to integer pointer, we're just gonna use int star. Let's do the same thing here again, but this time we'll do it for weight is equal to int star malloc of size of int star w. Now you can also do this for two-dimensional arrays, but I'm not going to do this for two-dimensional arrays because learning to do this for two-dimensional arrays for now is going to become slightly difficult. I'll repeat, it's going to become slightly difficult. So I'm just going to create in a different way. If you guys are interested, you can feel free to learn how the same thing works. So let's go ahead with this. Once we have all these values, let's copy the same code and paste it here. This time, instead of reading price, I'm going to read weight of each element. Remember, we are reading in the same order: number of elements, price of each element, weight of each element. Then we'll go for the capacity of the bag. So we'll read finally scanf percentage d, comma, ampersand w. W is the capacity. No, I don't want to do it in a single function. We can create a new function called knapsack, send the values to the function and get the result. Or if you guys want, you can do it in main itself. I don't want to do it in main because we always learn modular programming. So I'm just going to call another function called knapsack, which is going to return our maximum value, and we're going to send here the values, that is first number of elements, then the price array, then the weight array, and then finally the capacity. So we need to receive it here in our knapsack function. So let us create knapsack function here and receive the same thing. First thing we are sending here is number of elements. So let us read over here as int n. Number of elements we have read as n itself. And the second thing we are doing is sending price. And in order not to confuse, I'm just going to read it as price itself. And the next thing we are receiving weight, I'm just going to receive it as int weight as well. And finally, I'm receiving the maximum capacity. That maximum capacity, whatever we have as w, I'm gonna receive it as w itself. So guys, one small error. This is supposed to be n. Please note, it's supposed to be n. I've just made one small mistake over here. So I hope that is now entirely clear. So we have read all n, and then price, and then weight, and then w. So once this is done, let's go ahead and start looking at our knapsack problem. Now, here's the thing, guys. I need a couple of new variables here. So these new variables, I'm just gonna write it for now. One thing as int I. I'm just gonna explain why we need that later on. And we need another array, another two-dimensional array. That is, we'll call it as nap of. Remember the size of the two-dimensional array? Rows will be number of elements plus 1, that is n plus 1. Columns will be whatever is the capacity plus 1, that is capacity plus 1. So here it will be int nap of number of elements plus 1 and capacity plus 1. This is the size of the two-dimensional array we are supposed to create here. So I'm just going to create it just as it is, like this. You guys can try it out in C. You're going to get different answers. You guys can try it out in different cases. The answer here is going to be very different. So if you guys want to create this directly using malloc, you're going to need to learn more within malloc. And if we start doing that, it's going to take a long time. So I'm just going to keep it like this for now. Let's see what happens with this. Let's just keep it like this. So this is supposed to be n plus 1 rows, w plus 1 columns. 3 elements, that means 4 rows. 6 capacity means 7 columns. Once we have created this, the first thing is we need to start storing the values here. So we need to create a for loop for I equals 0, I less than equal to n, I plus plus. That is for each row. Number of rows we have is from 0 to n. Remember, we have 3 elements. Number of rows we have is 0, 1, 2, and 3. That is 0 to n. So we are going for each row. In that, we need to go for each column as well to access individual elements. So I need to create one more for loop here, that is for now j. So since I need to use one more, I'm just going to use j. And please don't get confused, guys. I here represents row number, j here represents column number. So j is equal to 0 and j less than equal to, the condition is it should go on till index 6. Index 6 is the maximum capacity. So I'm going to take j less than equal to maximum capacity w j plus plus. So this is how we will go through every value. Now let me give you guys one small clue, a half a clue I'm going to give you guys here itself. If I is equal to 0 or j is equal to 0, what should be the value of nap of I of j? I'm going to ask you guys this question. I'll just wait for a few seconds. Let's see how many of you guys do get it right. If I equals 0 or j equals 0, that is, if row number is 0 or column number is 0, what should be nap of I of j value? Right. Simple. We just have to make it 0. Because whenever row is 0, that is, number of elements we are storing is essentially 0. When capacity is 0, number of elements we are storing is basically 0 as well. So we're going to make nap of I of j as 0 here. Now once this is done, now comes our else part. In else part is where we put up our equation. Our equation here is, observe this. So I'm just going to copy this equation, paste it here. We're going to try modifying this. So in our case, it is nap of I comma j is equal to maximum of, we have our max function here which gets our maximum value, max of nap of I minus 1. Note this, guys, max of nap of I minus 1 comma j comma nap of I minus 1 and something else. Now here we're gonna encounter one problem. I'll tell you guys what is the problem that we'll encounter. Don't worry, I'll explain the exact problem we'll encounter. So here the second condition is, it is max of, sorry, nap of I minus 1, which is row number. And what about the column number? Observe, guys, here it is, column number is j, column number minus whatever column number we have, the capacity, minus weight of ith element. Now how do I get weight of ith element? We have an array called weight. I need to access this array and get ith element weight. So I need to access weight of ith element. So if I want to access weight of first element, I'm going to access weight of 0. If I want to access weight of second element, I'm going to access weight of 1. If I want to access weight of third element, I'm going to access weight of 2. So all I need to do here is access weight of I minus 1. That is ith element. We're going to use weight of I minus 1. So this is your entire first part of the code. The second part is, you're going to have to add this. I'll repeat, you're going to have to add this with price of the ith element. Price of ith element will be calculated as price of, again, I minus 1, same as before. So this is your basic formula. So let's see if it works. If this works, finally, whatever value we get at the last part here, final part, whatever we get the value here, that is supposed to be the maximum capacity we can store. By considering all these elements, whatever will be the maximum capacity, will be the maximum price that we can store if the capacity is 6. So we need to get the value that is here. The value that is here is 3 of 6. In other words, n of capacity. So we have to return at the end, after this entire for loop, we have to return nap of I value should be n, j value should be capacity, number of elements. So I'm supposed to return map of n. Sorry guys, and guys, please note one more minor thing. Please note here one more minor thing. Since we have been comparing as I comma j here, I've just written the same here. Please note it's not I comma j. In your programming, when it comes to C, you have to make sure it is I of j. Since we were executing in the same way, I've just written it the same. But please note, it should be I and j in separate indices. So I have to do the same here. It is I of j. So that now makes it clear. Nap of I of j. Now all we need to return is nap of n of the final capacity, that is W. So let's try to return it, and whatever is returned here we are supposed to print it. So I'm going to put this function itself in printf, percentage %d comma, I'm just going to use slash in here for easiness, and I'm just going to run this. Let's see what will happen. Will it work or will it not work, basically? So once I compile this, I'm going to get one error here. That is, I have not declared I somewhere. Let's just observe here, line number 30. I've not declared I here, so I'm just going to declare I, which we haven't in main. So that's our first error that we have obtained. So let's execute. So to execute, I'm going to take the same problem that we took up earlier, where we were supposed to get the output as 8. So we had, first thing is 4 elements. The price of the 4 elements were 1, 2, 5 and 6. And the weight of the 4 elements were 2, 3, 4 and 5. And the maximum capacity of the bag that we took was 8. When we took this up, I'm getting the final answer as 12. So here it basically says that 12 is the maximum capacity we can take it out. Now with a bigger question for us to solve again, it may become slightly confusing. So let me take a simpler, easier one, the first one that we took. So I can solve it right ahead and show you guys what exactly we are missing and what do we need to do in order to solve that missing case scenario. Observe this, guys. I'm going to take very simple case. Take 3 things, 1, 2, 3, 3 values, and their capacity, their values are, let's say, 10, 15 and 40. So capacity is, let's say, 6. If capacity is 6, all 3 weights can be stored. That means price will be sum of all 3. So price should be 65. Let's see if it is correct. Let us try the same thing. I'm going to execute this. 3 elements. Those 3 elements are 1, 2 and 3. And the weights are 10, 15 and 40. And the capacity is 6. When you take capacity as 6, you're getting output as 3. You're not getting output as 65. The reason here, I'll repeat, guys, please observe this very carefully. The reason here, I'm going to print the entire array at the end before returning. You will get a better idea. The reason I'm doing this is because if modifications of such programs are asked, you should be able to solve and figure out how to do this. Now, I'm just going to print, let's say, percentage %d comma nap of I of j. I'm just going to use slash t here for our case, and I'm just going to use printf slash n. Now I wish I had taken the much previous program that we had. I had not erased that to replace it with this. That would have saved our program data here, which we could have used again to compare. But since I have erased this, I'm just going to take the current one itself again. Let's compile, let's run again. 3, 1, 2 and 3 are the, sorry guys, let me just check. Price, or sorry guys, one mistake, one slight mistake. I'm supposed to read the price first. Price is 10, 15 and 40, and the weight I'm supposed to read next. The weight is 1, 2 and 3, and maximum capacity is 6. You're able to get this entire logic where the final value is 65. That's basically it. Sorry guys, please note, I just read the opposite things. I'm supposed to give the input of price first and weight next. Don't make such mistakes in programming. Since we were going through multiple pages and I have to explain and check comments, sorry for the slight mistake. So I hope this helps it clear out. This one simple formula is all you need to know to find out the maximum profit. Now, before I go on to the next kind of interview questions that you can possibly expect from knapsack problem, let me know guys if there are any questions, any doubts still here. This is your simple and easy way to solve this. If there are any questions, let me know guys. If it is easy for you to understand now and solve, then that's perfect. I'm going to remove this for loop. It's just this one little code. This one little line of code is all you need to know. And this is how you can dynamically perform or perform dynamic programming to solve many such questions. And I will list out what other type of questions can be asked and how do you solve them. But until then, I'm going to give you guys a minute of time. Any questions at all for now, if you guys have, you guys can feel free and ask. I will make sure to answer the same. So I am assuming there is no other questions when it comes down to this. So I hope it is clear. All right, so let me just go with the kind of questions you guys can expect from this. Now, this is your simple knapsack problem. We understood how to solve it basically. Now that we understood how to solve it, let me guys give you a clue of some other kind of questions you can expect. Think of this, guys. A student is writing an exam and the student has 60 minutes to write the exam. Now, the moment you see this question, you may feel like I have no idea how to solve this. But once you know the basics of knapsack problem, you can easily solve this. Think of this, guys. A student is writing an exam. He has 60 minutes to write the exam. Now, the student has n questions in the exam paper, and each question takes a certain x amount of minutes. I'll just write it in the next line. Each question takes a certain x amount of minutes. Given that you know how many questions are there and what is the minutes required to answer each question, I'll just put it in the next line so you guys can see the whole question. Given that you know how many questions are there and what is the minutes required to answer each question, find out how many marks can the student get at maximum. So when you look at this question, it looks very confusing. You're like, oh god, I'm not going to be able to solve this. I'm just going to skip it. This is basically going to be our first reaction. But let us look at this and let's try to find out if we can possibly solve this. So 60 is the maximum minutes. So I'll just write max minutes is 60. Now followed by this maximum minutes being 60, we have n questions. Let's say number of questions is, let's say 10, or 6. Number of questions is 6, and each question has a certain x amount of minutes to solve. So there's question 1, question 2, question 3, question 4, question 5, question 6, and each question takes certain x minutes to solve. So let's say question 1 takes 15 minutes, question 2 takes 20 minutes or 30 minutes, question 3 takes 15, question 4 takes 14, question 5 takes 19, question 6 takes just 1 minute. And each of those questions has some marks associated with it as well. It's not just x amount of minutes. Each question has a certain amount of marks associated. So let's say question 1 has 20 marks, question 2 has 5 marks, question 3 has 5 marks again, question 4 has 10 marks, question 5 has 15 marks, question 6 has just, let's say, 5 marks. Now they're asking what is the maximum number of marks the students can get. Now this is exactly the knapsack problem asked in a different way. Think of this, guys. There are 6 treasure items. Maximum capacity is 60. The weight of each treasure item is the same, that is number of minutes taken to solve this. Maximum minutes is 60, number of minutes to solve is this much. So basically you have 60 as maximum capacity, and this is the weight of each question or each problem. And this is the price of it, this is the value of it. So they're asking you what is the maximum value you can get for this max capacity 60. Does this make sense, guys? Does this sound similar to a knapsack problem? Let me know, guys. Does this sound similar to a knapsack problem? I want you guys to respond in the live chat, and I want you guys to let me know if you feel like yes, this does seem like the same problem. This does seem like a knapsack problem, or do you feel like no, it doesn't seem like a knapsack problem? Then I will go ahead and try to explain it a little. So you guys let me know. Does it seem like a knapsack problem for you guys? Where 60 is like the capacity. In a time limit of 60 minutes, you need to figure out for each of this question based on the minutes it takes. So 1 minute I can store 6th question. For 19 more minutes I can store 5th question, and similarly you have 40 more minutes. So which questions can you possibly store? And by the end you need to figure out what is the maximum marks you can get for it. That is, the price will be maximum. So we're gonna have to do the exact same logic. There's no difference in it. As a few of you are pointing it out, it's the exact same thing. So when you get questions in the TCS Digital particularly, these are the kinds of problems you may expect. So I hope this makes it simple to solve at least this one problem. So the same thing, I'll repeat, guys, can be asked in very different ways as well. Now this is something simple, we understood this. The same thing can be asked in different ways as well. Ram has gone to a shop. Ram wants to buy certain amount of chocolates for 100 rupees, and he wants to buy the chocolate which is the most tastiest. Ram has written a taste scale accordingly. So find out which is the most tastiest values candies he can get. So it can be asked in many different cases, and it has been asked like this in interviews. So you don't have to do anything else. For this question, you basically have to do the same answer. That's it. Now comes up a different question. If they ask, I'll repeat, if they ask, also print which questions does the student need to answer. They're asking you not just number of questions that the student needs to answer, they are asking you which questions does the student need to answer. When you start solving this, you're gonna need to do extra. You're gonna need to find out a different logic at the end for this. So you're gonna also have to find out for let's say that value, whatever you get as maximum, you need to create one more thing here called maximum. And every time you start storing this, let's say I have something else called int max equals 0. That is basically maximum number of elements, or maximum value that is there is 0. So every time you're updating this in else case, I'll repeat this, students. If such question is asked, every time you update this in else case, you need to check if knapsack of I of j is greater than maximum, you have to make maximum equals nap of I of j. And once you make maximum equals nap of I of j, you need to figure out which are the elements that are stored in it. To figure out which are the elements that are stored in it, you need to go back to the coding part of it. If nap of I minus 1 comma j is the maximum, then the elements stored are the same as previous one. That is whatever the element is there in previous case. If it is not the case, that means the current element plus previous elements together are stored. That is basically what you need to store here. So that again requires a lot more logic here. Now that you guys have the basic idea of this, I hope you guys can try this out with this simple logic. I'm going to leave this one question to you guys, and since we have so many other types of questions which can be asked as well, I'm going to go for a different question over here for you guys now. So the next question I'm going to go ahead for is something entirely different from these, which is also a pretty common question. And this has been asked multiple times as well. Take this for instance, guys. You have a matrix. And before this, I'm also going to state one question which we will not be able to cover because it takes much more time for us to learn graph theory and basically everything. You can expect something like minimum spanning tree, minimum spanning tree problems. That is a traveling salesman problem. As you guys know, traveling salesman problem. A truck is traveling from one city and it has to travel to 4 or 5 cities. Now, how many cities can it travel to in a short to make sure that it is conserving as much fuel as possible? So there could be something like city 1, city 2, city 3, city 4, and they will give you the path distance from each city. So this will be given as a matrix. City 1, 2, 3, 4 to city 1, 2, 3, 4. What is the distance? 1 to 1 the distance is 0, 2 to 2 distance is 0, 3 to 3 distance is 0, 4 to 4 distance is 0. 1 to 2 it can be 10, 1 to 3 30, 1 to 4 40, it could be anything. 2 to 1 it could be something like 30 due to different roads, any such thing. In such cases, you need to find out if you're starting from 1, which is the shortest path and how much kilometer do you need to travel. So finding this is basically traveling salesman problem and minimum spanning tree. So to do this, we need to learn how to work through graphs and everything, which is going to take so much time. So this is one thing I suggest you guys to try going through. I'm just going to point it out here because this has also been asked. That is traveling salesman problem and minimum spanning tree. You guys can look at things like Kruskal's algorithm, Prim's algorithm, and Warshall's algorithm, and Floyd algorithm if you really want to learn all of these. Because I'll repeat, if we start graphs, it's going to take at least 2-3 hours for us to work through graphs, at least. So you guys can try going through this if you have your old lab manuals, or just search any lab manual, you'll get these codes. Basically, trace it out, you can try to understand it. But the problem I'm going to just try to go through and explain here is permutations first. This guys, take a string ABC. What are the permutations you have here? You have permutations like ABC, then ACB, then BAC, then BCA, then CAB, and then CBA. You have all of these permutations. Now, how are you going to calculate all these permutations? It's not an easy task. It again requires some difficult work here. You have to do a lot of things here. So this is one very common question that has been asked in your interviews. You need to find all the permutations of a given string. I'll repeat, you need to find all the permutations of the given string, and you need to figure out how to find out each permutation, and you need to perform some action with it. Like, for example, I'll give you guys one instance. Once you find out all permutations, you need to figure out how many of its permutations are palindromes. So a question can be given a string like something like, let's take a simple thing like madam. This is a string. They're asking you how many permutations of this can be a palindrome. So first you can take it as madam, which is a palindrome. You can even take it as AMDMA, which is also a palindrome, or you can interchange these M in different ways. That can also be a palindrome. You can interchange this A in different ways. That can also be a palindrome. So how many permutations of this can be a palindrome? Such questions can be asked. To do that, you need to figure out how to find whether a string is a palindrome or not. So let us try figuring this out, guys. So one question I want to ask to all of you guys. Before we start this, do you guys want to take a small break here and start at 8:30 and begin this? Do you guys want to take a small break of, let's say, 4-5 minutes? Do you guys want to? And start at 8:30. Okay, so I would assume there's no break required, so nobody is asking for a break. So let's directly go ahead in that case. So let's begin with this. When we talk about, I have received one more question. Until when shall we continue with this? I'm only going to take two more programs, just two more programs. We'll see how long it requires for this. I'm going to try to cover them as early as possible, possibly 10 minutes per program at maximum. I hope I'll be able to finish these off. I'm hoping. So maybe 20-30 minutes at max, I'm going to take, not more than that. So let us try it out. So here's the basic idea, guys. Given a string, if you want to find out permutations of a string, here's what you need to do. You need to perform this in multiple ways. First, take ABC in the first way. That is, first character is constant, permutate the other thing. That is, here it can be ABC and ACB. Then take the same thing over here, ABC here. Now exchange this B to start, and let's just take this as BAC. Again, you have to divide this as, let's say, BAC and BCA. Again, let's go ahead, here. Let's take the last character at the start as CAB. Again, you have to divide it as CAB and CBA. I'm going to try to explain this in short as early as possible, so you guys can get to understand this as quickly as possible. We're not going to take much time. The idea to do this is start with one character at a time and swap. See, guys, I'm swapping A and B. Then I'm swapping A and C. See, here's the idea. When I have ABC, if I want to get BAC, I need to swap A and B to get BAC. That means after I perform the swap to ACB, I need to make it go back to ABC. Understand this idea, guys? I have my initial string ABC. I'm gonna make it as it is ABC, and I'm gonna have first permutation as itself ABC, second permutation as modification of these two ACB. Once this is done, I need to put it back to its previous form. I need to unswap it. So basically, observe this, guys. I need to unswap it back to its original form. So when we unswap it back to its original form, I get ABC again. that is when I can swap A and B to make it BAC. In the BAC, again, I need to perform permutations. I need to check first permutation, which is BAC. Second permutation, again, swap these two characters. I'm going to get the permutation BCA. Once I get this permutation, I need to unswap it back to BAC and I need to unswap it back to ABC. Then once I get ABC, or at least once I have BAC, here I can swap C to B and I can get CAB basically. That is the basic idea. So to do this, let's take a simple string. I'm not going to take a complicated string and I'm going to do this as quickly as possible, because remember guys, if permutation based program are asked, you can just implement the code that I'm sharing here. After implementing the code that I'm sharing here, you guys can then create additions on top of this to perform, like to find whether palindrome or anything like that. Such questions are often asked, so let us try doing this. So let's take int main, and I'm not going to read any user input to save time. I'm just going to take a character array of some 5 elements and I'm just going to store it as ABC. This is basically what I need to perform permutation of. And I'm just going to call permutate of the string. Now here's the thing guys, every time you permutate, you are calling it recursively. Here you're keeping first character constant and you're permutating next two characters. Here also you're keeping first character as constant and permutating next two characters. If your string is lengthier, like let's say madam, you're going to keep first character as constant, permutate the rest. When you do this, you're going to keep first character as constant again, permutate the rest. Here you're going to keep first character as constant again, permutate the rest. Here again, first character as constant, permutate the rest. When you reach last character, you can't do anything. That is where you stop. So this is our whole idea. So we need to call it recursively, where we need to know which is the starting index we need to permutate from and which is the final index we need to permutate till. So we need to send two other values apart from string, that is starting index where to permutate from and which is the final index. Final index will always be length minus 1 because it has length of 3. I'm going to have to give 3 minus 1. So to find length, I'm just going to take int n equals str len of str. So I'm just going to write here as hash include, sorry guys, I'm just going to write here as hash include string dot h. So I hope this for now makes it just clear what exactly we are doing. I'll repeat this guys, please observe this very carefully. This may be slightly confusing to get initially, so please observe this very carefully. I'm just going to try explaining this. When we have A, B, C, I'm going to take this whole thing to permutate. In this whole thing permutating, first thing I'm going to take is keep A as constant and permutate only B and C. When we permutate only B and C, my starting index is 1 and my final index is 2. I'm supposed to permutate between index 1 and 2. So I'm going to get here as two values. One is ABC, another one is ACB. Once I get these two, I'm supposed to unpermutate, go back to this. Once I go back to this, after unswapping, I'm going to take ABC and now swap permutate it again to BAC and basically start this whole step. So I'm just going to explain this code in short. Otherwise, I will repeat. This code is going to take a very long time for us to understand if we go through every part of this. So we will receive it as a function permutate, where we're going to first receive a character array, that is character star str, and we're going to receive two things, that is starting index. I'll just take it as let's say we're just going to take it as index start, and I'm going to take one more thing called index end. So initially starting index is 0, ending index is n minus 1. So when we reach, when initially I need to swap all three, then I need to swap these two, then when I reach the final case, my starting index is also same, my ending index is also same. Both are basically C. Starting index and ending index both are 2. When both are basically 2, I don't need to perform any swap here. I just need to print this final value. So the idea is when my starting and final index, that is if start and final index are equal, I don't need to do anything else. I'm just going to print %s/n comma string. That's it. If my start and end index are not same, then I need to go through this entire thing and perform permutations and solve them. So let us try. So basically what we're going to do here is, for again I'll repeat this, we need to loop this from starting to ending index. In the first case, starting index is this, ending index is this. I need to perform for all three. In the second case, starting index is this, ending index is this. I have to perform swap only for these two. So I have to have a for loop for, let's say, I equals starting index, I less than equal to ending index, I plus plus. So we're going to create one more variable called int I. So for from starting index to ending index, we're going to have to swap. After swapping, we're going to have to basically, I'll repeat guys, please observe, we're going to have to swap. After swapping, we're going to have to permutate. After permutating, we have to unswap. We have to perform the reverse of swapping again. So let us see what exactly happens here. So in this case, I hope I am audible perfect. So in this case, all that we need to do here, guys, is just observe this. Let us perform swap. Now, what exactly are we supposed to be swapping here? So in swapping, remember guys, in our code, we're gonna have to swap starting index, that is starting index, with each of the other index. I'm supposed to swap this starting index with the next index and its next index. So the next index and its next index start with our variable I. So I'm supposed to swap our value a of start with a of I. And in the last case, I'm supposed to unswap the exact same things. Once we do this, before swapping, between swapping and unswapping, we just have to perform permutate again. But observe this very clearly guys, one small thing. Once I swap, this is one basic thing we need to know. In ABC, once I swap A and B as BAC, I'm supposed to permutate only these two. I'm not supposed to permutate the starting at all, first index at all, because B is going to be constant. So all I'm supposed to do here is, when I permutate, I'm going to give the string A. Sorry, we have received it as str, so I'm just going to use str here, not A. We're going to take the string str and we're going to make sure our starting index now is not start. Instead of start, it is going to be start plus 1 up to end, because start is already constant, its next two must be swapped. Here when we go ahead, again it's going to swap a comma c to b c a. In this case, when you perform swapping of these two, c and a, here's basically what happens. Once you have done the swap, next you're supposed to swap start plus 1 and end. Since start plus 1 and end are same, there's no need of swapping again. You basically cannot swap again. So in that case, in this permutate part, once you go ahead, since start and end are equal, it can't swap again. It's just going to print the string. Let's see if this simple logic will work for us. I'll just compile. There are a few errors here to begin with. That is, the first error I'm getting is there's no function called swap. Let us create a function called swap. I'm just going to use void swap, and we know how to do call by address and swap. So I'm just going to receive these two characters as char star, let's say A, and char star B. We're just supposed to swap them. So we're just going to take char temp equals value of A, and then A will be replaced with B, and then B will be replaced with temp. Once we have done this, swapping is also done. Let's see if it works now. Let's see if there's still any errors. So we can see that we have not written the function name, probably perhaps. We are supposed to have it permutate, not permutate. There's a small typo here. Let's solve that and let's try to compile again. Over here, you guys can get a couple of errors here. The first error here is it says you are sending str of start and str of I. Observe this very clearly, guys. With this, we'll also be able to understand when we get such errors, how do we possibly solve it? So in swap, if you see, we are sending str of start and str of I. That means we are basically sending a character. When we send a character, I can't receive it in an address here and swap. So when you send a character here particularly, you can't receive it as an address. So what we would need to basically send is address of this character and address of this character. So we can swap them. Once we send addresses, we need to receive it as pointers and swap. Remember guys, when you send a string name, it is an address. But when you send a character value is not an address. Character has a value. You need to send basically as address of it. So now that we got this basically clear, let's see if at least now we can compile the program. So let's try it out. So I'm just refreshing the chat. Okay, there's no questions. All right, let's try it out, compile and run. Now we are able to get all the 6 permutations. So once you get all the permutations, you can perform anything you want. Like if they ask you to print all the palindrome permutations, instead of printing it, create one more function called palindrome, send it over there. If they ask you to print only the permutations with a certain condition, you can even do that. So this is your basic logic to print permutation of strings. So I'll just state here, permutation of strings are printed. So going ahead from this, I want to go for one last program for you guys, just one last program. But I want to give you guys a clue first before we solve it. And then I want to ask you guys if you guys can solve it directly or if you guys need my help to solve this. So let us try doing this. Let us try solving it out. Let's try our final program. And I hope of all the programs we have gone through till now, it's become easy for you to solve through. And before going on to the next program, I just want to point out one more thing. Guys, further on, if you guys want to go through our programs in Quantmasters, you can go through descriptions of any other videos that we have and check it out and contact us for any programs that you may want to go through. I've seen a few of you guys have already enrolled to our programs and the same names I'm seeing here. Nice to see you guys being active here as well. But for those who haven't gone through this, who are seeing this video later on or any such thing, you guys can enroll through our program. Just go through descriptions of any of our videos and you guys can communicate with us to get to know more about the programs that we offer. Anyway, let's go for the final very important program. Here's the idea. You have a let's say 2D array like this, 1 2 3 4, and let's say 5 6 7 8 and 9 10 11 12, and finally 13 14 15 16, always a square matrix, assuming. Now all that you need to do here is print this matrix in a spiral form, that is start from 1 2 3 4, then 8 12 16, then 15 14 13, then 13 9 5, and then 5 6 7, and then 7 11, and then 11 10. This is the order in which you have to print. So your output should be 1 2 3 4 8 12, 16, 15, 14, and 13, 9, 5, 6, 11, and 10. Do you guys want us to try it out? Is this simple, or do you guys find it a little difficult and you want us to solve it? Let me know, guys. If you want us to solve it, we'll go ahead and solve it. Or if you guys think like this is something that is way too easy, then I can just give you guys a logic and we don't need to work through this. You guys let me know, because this is also a very common question where they ask you to perform something like this, either in a spiral clockwise or a spiral anti-clockwise, and they may ask you to start from any index and end it at the center, or start from end center and end it at the edges. So I will be looking for majority of responses. Let me know, guys, what do you think? Do we solve it, or is it too easy? And again, I'm not going to take a long time. This is the last program. I will also try to solve it in short as quickly as possible, and it is very easy, not to worry. Okay, so one of you have already gotten the exact same question in one of the interviews. All right, this has been asked in previous interviews as well. So, all right, let us go and try to solve this. So, here's the basic idea, guys. We're going to start with, let's say, let's create an integer array to begin with. I'm going to delete all of these things. We don't need any of these. Let's create an integer array here. I'm just going to call it as int ARR of number of rows and columns. So let's say rows are 4 and columns are 4 as well. And this we basically store as expected: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13, 14, 15, and 16. We know that the output is supposed to be like this: 1, 2, 3, 4, 8, 12, 16, 15, 13, 9, 5, 6, 11, 10. They may ask you to use a comma in between, or print it in next or new lines, or anything else. They may ask it in any way, but that is not something we need to worry about. Let us try solving this. So here's the thing, guys. To print it in a spiral form, I'm going to create a function that is called spiral. And in the spiral function, I'm going to receive this array. Again, as usual, we always learn to do modular programming where we create functions. That is why I'm calling a function called spiral here, where I'm going to send array name and the number of rows and the number of columns. So you can even have this entered by the user if you want, and store it like this. That is also easy. I'll just tell you guys how to create this memory allocation using dynamic memory allocation. So I'll just tell you guys how to do this. Let's take an integer rows and another integer column. All you need to do here is scanf %d ampersand row, and then scanf %d ampersand column. Now here's the thing, guys. If you want to create a two-dimensional array of this, you need to create in malloc something that is 4 into 4 into size of array. That's it. 4 into 4 into size of array, and then you can access it. But if you need to access it using malloc, you need some special things. So that again, I'll leave up to you guys. If you really want to learn those separately, you can. It's not so much needed for our program for now. So let us receive this. I'm going to receive this as int star ARR and int rows and int columns. So now that we have received it here, basically, let us start with our code here. So I have to take multiple variables here for us to go through. I have to go through everything from left to right, then top to bottom, then right to left, then bottom to top. I have to repeat these steps like this. So first thing I need to do is go through all the elements, but the first thing I need to do is go from left to right. So the condition here is your indices are 0, 1, 2, and 3 here, and your indices here also 0, 1, 2, and 3. It cannot cross index 3 here. It cannot cross index 3 here. So the condition is it can only go maximum up to here and maximum up to that particular index. It can't cross row and column index. So to iterate through row and column index, I'm going to take a couple of variables, that is integer I comma j, and I will be equal to 0, j will also be equal to 0 initially. So I is a variable which is initially 0, j is a variable which is initially 0. Now, since the idea is I is going to go for rows and j is going to go for columns, we're going to use a for loop for I less than equal to rows and j less than equal to columns. So in this for loop, we're going to have to start figuring out how to print everything. Now the first thing we need to do, guys, remember I need to print first row of data. To print first row, I need to print row of data first. So let me do the code here to print row of data. That is, all I need to do is use again a for loop to go through this entire row. So since I have used I and j here already, I'm going to use one more variable called k. So I'm going to use something here like, let's say, for, remember guys, we are printing only the first row. To print first row, I'm going to start with 0 until I reach number of rows, m. So I'm going to create a for loop for k equals 0, k less than number of rows, k plus plus. So in this loop, all that we need to do, I'll repeat, all that we need to do is print percentage %d slash t. I'll just use slash t so that we are able to differentiate, comma, array of row value, column value keeps differing, but row value remains as I. I is the first row that we are printing. So row value remains as I, array of I of column value keeps changing, that is k. So sorry guys, one thing to note here, please note, uh, row value remains as I. I'll repeat, row value, as we know, basically remains as k here. I'm sorry guys, row value remains as k because k is initially 0 here. That is the row we are basically starting to print, and this k value should take the row number, because second time when we are doing, when I is 1, we should start k is equal to I itself here. When I is 2, when we are going for this row, we should start from I equals 2 here itself. So that is the basic idea. So for each row, all that we are doing here is, observe guys, for k equals I, k less than equal to number of rows, k plus plus, and all we are printing is row value will be same, but the column value we should keep on changing. Is that correct guys? Row value is same, column value you basically keep on changing. So when you keep on changing the column value here, the column value is, as we know, what is the column value here guys? Is that k or is that something else? Think through guys. Is this logic correct? I'll repeat this, please observe. I went through column wise. So think through guys. First row is what we need to go through. I'll repeat this. We just need to go through first row. So all that we are doing here is, I'm going to give you guys half the code for this, at least for today, so that you guys can go through it and try it out, at least minimum. So let's start with the first row, so that I want to give you guys as a small assignment as well, which is going to be easy, not to worry. So let's start with the first row. So we are in the row value of I, but remember, for ith row value we need to change columns. So k should not be less than rows, k should be less than columns. So k will change for each column, and we're basically printing a of I of k. Let's see if this works. Let's see if only this works. If we only compile this, I have one little issue here. Let me just check what exactly is the issue that we have here. That is, it states a semicolon is expected. So yeah, of course our function should have a return type. Let's just make it a return type as spiral first things first. Once it is done, let us try compiling now and see whether we get any error. We still have one little error here. That is, it says expected semicolon before the bracket in this for loop. See guys, in this for loop, you have your set of brackets where you have your statements, and the inner for loop. I have one question. K, yes, as Priyank also stated, yes, K should be number of columns. That's absolutely correct. In the first case, please remember guys, you have row which is the same, so row will be array of I, but column value will keep changing as K. That's the basic idea. K will keep on increasing. So that's our whole logic. So once this is done, you're supposed to print array of I of K. But if you try looking at this, you get an error here, which is at line number 5, particularly stating that for I less than equal to rows and j less than equal to number of columns, it states, I'll repeat, it states that you're missing out a comma in line number 5, semicolon. And when you go ahead with this, it also, let me compile again guys, sorry. I have saved this, so we'll compile again. And it also gives us an error here, that is, there is a semicolon expected before this. That is basically because we have missed out a semicolon at the end of declaration of this array. Let's add that up. Now let's try it out, compile. There should be one now. That one error is basically within this line. It says semicolon is expected here in this case. That is, when you guys use this, please observe, this is supposed to be, sorry, our condition. Can I have only condition in for loop without semicolons? Simple question. Can I have only condition without semicolon in for loop? I'm surprised nobody pointed out to it so far. It's supposed to be a condition, right? I have to repeat throughout this whole condition. If this is the case, if you want to do it as a for loop, you're gonna have to use 2 semicolons here and here. Or if you want to make it, yes, as one of you pointed out, if you want to make it as a while loop, you can do the same. So this is the basic idea. So let us try to see if this basically works. So we still have one minor thing, that is subscripted value is neither pointer nor vector. Observe guys, please note this carefully as well. So there is one basic error where, remember, we are sending two-dimensional array. Two-dimensional arrays cannot be read as a single pointer. This is a basic thing we all should know. Two-dimensional arrays cannot be read as a single pointer. Two-dimensional arrays must be read as double pointers. Either you read it as double pointers or you read it as arrays like this. You have to do one of this. This is the basic idea. If I change it to this and I compile it, there's again an error. It says dimensions are not specified. That is because whenever you read an array, number of columns must be specified. Since we are basically sending the array name here, we can receive it as, since we know rows and columns, we can basically receive it with the same variables, or you can also receive it as 2 double star or double star. Basically, when you go for double star also, again, it's compiler dependent. Just for our case, we're going to make sure we're going to receive it here as rows and columns. You can do the same here also, there's no problem in it. When you compile it, again, there's one small issue, that is we don't have columns specified here. That is because, observe guys, whatever you're receiving as rows and columns, you're receiving it afterwards, not before. You're receiving it after. So since we are basically having it before, if you want to receive it, you're sending it 4 and 4. Instead of sending it 4 and 4, let's just put it as variables so that you guys can understand it easily. I'll take int rows is equal to 4 comma columns is equal to 4, and this rows I'm going to send it here, and basically this column value I'm going to send it here. So we're going to, once you receive the same value here, now you will be able to do this. So these are some simple things that we need to work through. I have still one thing that is the same, is undeclared, unfortunately here. I'm just going to read it in the opposite direction. Or observe, guys, just because these are some compiler dependent issues which you may face in some compilers and you won't in some others. So I just want to make sure that we don't face this issue whatsoever. So I'm just going to store it like this, sending rows first, columns first, and then array. Let's compile now. There's no error. So here this is because I'm sending rows first, columns first. So I'm receiving it here. Afterwards, I'm receiving array of row and columns. So if I receive this array of row and columns at the start, the problem is I've not sent rows and columns yet, but I'm trying to receive it. But when I send it later on, I'm sending rows and columns before, then I'm receiving it. So I'll not get any error. So when you have a number of rows and columns, always send the number of rows and columns first, then receive the two-dimensional arrays. In some cases, you may need to recursively do this. So such function, receiving such function here will help you make it easy. So let us try compiling this and print this. Let's see what happens. In this case, it's an infinite loop. The infinite loop is because we are not stopping here. I does not increase to rows, j does not increase to columns, but I want to know output of only this. So I'm going to use break here to see exactly what happens. When I compile this and run this, I get to see 1, 2, 3, 4. That basically means I'm able to print first row perfectly. So my first work is done. Now after the first row, I'm going to have to go to this last column. So to go to this last column, remember guys, you need to keep count of which row you are in and which column you are in as well. So once all the rows are done, let's go to the last column. But in the last column, you're going to start from second row to last row. So the next thing here is go from second row. First row is done. Now I have to go from second row. So you need to keep a count of which row you're in. So I'm going to take another variable, current row. I'm just going to store this. Instead of current row, if you guys want, you can also increase this I value by 1, which points out to second row. So I'm just going to increase I by 1 to point to second row, because first row is entirely printed. I don't need I equals 0 anymore. So I'm going to make sure that our I value here, I'll increase. Once I increase I value, remember I is pointing here. And remember J is still pointing to the column number 0 itself. So what we are supposed to do is find out which is the last column and print of 3 for the last column. So to print of 3 for the last column here, you guys need to basically go through the same loop for k is equal to I, k less than equal to number of rows, but what you need to print here is last column. But remember guys, in the second iteration, you need to print last second column. If the whole array is larger, in the third iteration, you need to print last third column and so on. So you need to keep column number, not current row number. You need to keep current column number, which column you are printing, which column you are now going through. So current column we are going through is last column. So current column, we will store it with the value as columns minus 1. Observe this guys. Current column is columns minus 1. Column is 4 columns. Columns minus 1. So current column will point to 3. So remember this very clearly guys. I is now pointing to 2. Current columns points to column number 3. So in current column, I need to print from I wherever it is till it reaches number of rows. So let's do the same thing here. That is for, again, k equals I, k less than equal to rows, not columns. k less than equal to number of rows, you keep on increasing k1 at a time, k plus plus, because this time you're changing rows and not columns. Here you're going to print percentage d slash t comma array of, you're going to change the rows, but you're going to keep the column constant as current column. So once this current column is entirely printed, you're not going to use this column anymore. You're going to have to reduce the current column to its previous value. This will be your current column now. Once you reach this as your current column, then you can start this direction printing. So I'm just going to try printing this by using a break here. Let's see what happens now. When I compile this and execute this, I'm getting 1, 2, 3, 4, 8, 12, 16. That is, in our case, 1, 2, 3, 4, then 8, 12, 16. We got the first two places correct. Now, the next thing we are supposed to do is go through the bottommost row in right to left fashion. That means we are supposed to start from our current column value, keep on reducing until you reach 0. You need to change columns. So let us do the same here. We're going to keep on going in the second case for k equals current column, k greater than equal to 0. We are reducing it now. So that is why I'm going in this direction. K equals current column. Current column value is going to be pointing to this column. K greater than equal to 0, we're going to keep reducing k value. Here, we're going to check if k minus minus, basically the idea. So here, all that we're going to do here is print within the current, within this row, whatever this row value is, in this row, I'm supposed to print all the column values. So remember guys, this row value also you need to keep a copy, because next time you go ahead, this row value becomes here. This will be your current row value. So I need to keep a current row value also here. So I'm going to take one more variable, that is current row is equal to rows minus 1. So let us do the same thing here. What we are going to do here is print percentage d slash t, but I'll repeat this very clearly. What we are going to print here is using this current row. Row is going to be constant. K value will keep reducing from column. So all I'm going to have to do is print array of current row of k, where k is the value which keeps on reducing. Let's use our break statement here now to see whether it prints till here correctly. So now let's compile this and print this. I'm getting 1, 2, 3, 4, 8, 12, 16. But in the descending order, I'm getting something wrong. I'm getting some random value, after which I'm getting 16, which is not supposed to be obtained. Then 1, 5, 14, 13. If we see this, I'm only supposed to get 15, 14, and 13. That's all I'm supposed to get. I'm not supposed to get the other ones. But here, apart from this, I'm getting these random values. So observe this, guys. The reason here is, see, what is the current row here? Current row equals rows minus 1. So current row will point to the last row. Number of rows is 4. Current row points to 3. After this, we have current column, which particularly points to. Have we reduced current column here, guys? I forgot to tell you guys. Have we reduced current column? Current column was supposed to be this column. Have we reduced back to this column? We have not. We're supposed to reduce it first. So let us reduce current column by 1 here as current column minus minus. Once you do this, this is at least supposed to work. Let us compile and try it now. Once you try this, you still have one small issue here, that is after 16 you're getting these random values, and then 15, 4, 13. Observe this, guys. I'll repeat here. Here, your k value, you guys need to note and observe this very clearly. Current column was supposed to be the last column. We have reduced it by 1. Current row points to here. So current column points to 2. Current row points to 3. So we have the last row 3. We have the index 2 as well. So what is going wrong? Observe this very, very clearly, guys. This program, I'll repeat, can be asked in any different way. Any different way, as in you can expect this kind of problem in inside to outside spiral, outside to inside spiral, or clockwise spiral or anti-clockwise spiral. It can be basically asked in any way. So that is why, in order for us to try to solve this, here's what's gonna happen. We know, I'll repeat this, you guys need to understand this very carefully. Current row is rows minus 1, so current row points to row third. That is absolutely correct. Now when you talk about k value, k value is currently current row, sorry, current column. K value is current column. You are reducing it one at a time. So I'm just going to print along with this one more value to help you guess what happens. Two more values. Those two values I'm printing here is, instead of slash t, let me print it as slash n to make it clear. The two values I'm printing here is current row comma k. If you guys observe this carefully, you guys can see here in each of this is row, sorry, column 3 first row, column 3 zeroth row, column 3 second row. Then why are we getting this particular value? This particular value we are getting because here our condition is not supposed to be less than equal to rows. It is less than rows. Remember, row number is 4. Less than equal to rows will always give us the next value here, which is garbage. So you should never do that. I'm just trying to give you guys a few errors also so you can figure out where you're going wrong. So with this, now if I try, again, I'm just going to remove these to just show you guys the basic idea. And remember guys, sometimes you will have limited compilation times. You can't compile too many times. And again, I'm not supposed to have slash n. Let me just have slash t. Let's compile again, run this. We are getting exactly as expected. That is 1, 2, 3, 4, 8, 12, 16. After 8, 12, 16, you're going to 15, 14, 13. So once we have done with 15, 14, 13, this is also done. Our current column is here. Our current row is 3. Now this row is also done. So we need to go one row before. So our current row gets reduced to 2. So I'll just point this out. Current row now becomes 2. Now you have to print from your current row by going backwards until you reach row number 2. You should not print row number 1. You should print until only row number 2. So how do I get to know I should print only until row number 2? Think of this guys. When current row is 3, see, total number of rows guys is 4. And I'll just point it out here. I'll just try to point it out in short. If you have total number of rows as 4, 1, 2, 3 and 4, when you're printing from 4th row, when you've printed already till here, that is done. When you're printing from here back to here, how many rows have you skipped out? 1 row. So 1 row you have to skip out here as well. That's the basic idea. You have skipped out 1 row from the bottom. You need to skip out 1 row even from the top. So just remember, number of times you have to go through this is however many rows difference. Number of rows here is 4. 4 minus 2 is 2, or the last row here is 3. 3 minus 2 is 1. Since 1 is there, 1 row should be skipped. That is, you have to go ahead to the second row. Now from here, I'm going to give you guys as a small assignment to try from here. Again, this is not going to be difficult. I'm just going to give you guys a couple of clues and I want you guys to try it out from here. Can you guys figure it out? I'll give you guys the entire logic. Will you guys try it out? Let me know guys. If you guys can try it out, I'm going to give you guys the whole logic, whole clue, because we have done for, let's say, a couple of rows and columns. Now you have a clear idea. All that you need to do here is, I will give you a clue. Go for one column printing. Just print this one column. That's it. Once this one column is printed, then you loop again. In loop, you start the same thing again. You're going to start the exact same thing again in the loop. And when you start the exact same thing again in the loop, you have to keep on repeating it until you come up to a particular condition where you have finished the number of elements. And how will you get to know when you have finished the number of elements? This is not the code. Your condition will also differ. So can you guys try just these two things? What is the condition to find out if you're finished? I'll give you guys a couple of clues. One, you can try thinking of number of elements printed. You can keep a count of number of elements printed, or you can try thinking of row and column values as well. You can try it in both ways, number of elements printed or row and column values. And the other thing you have here is, when you're printing this column, all you need to do is go from last column minus 1 until you reach first column plus 1. In the second time, if it is 5 rows and columns, if you're starting from last column minus 2, let's say we have 1, 2, 3, 4, 5. If you're starting from last column minus 2, you're reaching until first column plus 2. That's basically the idea. So I hope that one logic, can you guys try by yourself? My simple question, can you guys try this one small logic by yourself? If this one logic is done, column printing, that is left side from last second to first second column. That is basically, I'll repeat, you're starting from, I'll just give you guys this clue if you want. If you want, I'll give you guys this one for loop as well. Let's start with this. We are starting from, remember guys, we are starting from current row, which is 2. Remember, current row we are supposed to reduce after this. We'll reduce current row to 2. Once we have reduced current row to 2, I only need to print these two things, nothing else. So when I'm supposed to print these two things, all I need to do is start from current row, keep reducing until I reach a value. That value is number of rows minus current row. So I'm just going to write for k equals current row, k greater than equal to rows minus, rows minus current row minus 1. Observe guys, k is equal to current rows. That means k is basically now 2. And k is greater than equal to number of rows. Number of rows in our case is 4 minus current row is 2 minus 1. So 4 minus 2 minus 1, I'm basically getting 1. So 2 is greater than equal to this 1. Yes. Then start doing it. Start reducing k minus minus. And here you're going to print again percentage d slash t comma array of array of k of current column. Now, can I print it as current column here? One more question to you guys. Can I print it as current column? Because current column is here, 2. I can't use current column. I'm supposed to use 0 here. So, same logic you need to use even here. You can't print it as current column directly. You need to print it as columns minus, observe this guys, this is entirely done. We are now here. These are your rows and your basically column you're basically accessing is 0. Once this is done, you will be having only these two columns after that, just these two columns. So all you need to do here is make sure for the first time it is 0. For the first time it is 0. For the second loop this becomes 1. For the third loop this becomes 2, and so on. So let us try this. Let's see what happens. If I compile and execute, I'm basically getting 1, 2, 3, 4, 8, 12, 16, 15, 14, 13, 9, 5. So all you guys need to do is figure out here. I'm going to give you guys 2 clues. All you guys need to do is figure out, replace 0 in such a way that you get it subtracted with current column. And after this one thing, all you need to do is change this condition. These are the only 2 little things you guys need to do. So will you guys be able to do this? Can you guys try doing this? That's all. We have done most of it. I'm giving you 2 very small and minor things to do. Can you guys try doing this? That's all. So give guys just a couple of small things. Now that we have done all of this, the rest should not be difficult. Now that we have done all this logic, the rest should really not be difficult at all. So I want you guys to try giving this a chance, or try figuring out. It's not going to be too difficult. I'm sure you guys are going to be able to solve it very quickly. So think through and try it out, guys. And I'm just going to point out to a few things now. Please note this very carefully. For your TCS Digital, you're going to expect such questions which are going to be based on dynamic programming. And we started with dynamic program. I'm going to share the whole file to you guys now, so that you can access all this code to revise and try out as well. So we started with something simple, even if it is something simple like Fibonacci, how can we use dynamic programming? And we learned sliding window problems, which can be solved for these people sitting next to each other, the marks problem, and as well as maximum average sub-array problem. And we also learned how to work through some string questions, and we learned how to work through knapsack problems, what combinations, what certain different questions can be asked in that. And finally we saw how to permutate a string, and I gave you guys a small clue on how to spirally print something, a 2-dimensional array, and how to not completely do it, partially. So I want you guys to try this out, and I want you guys to just search out data structures lab manual and your algorithms lab manual, and make sure you guys go through as many programs in it as possible, which may also help out, and try them out. So I'm going to copy and share this code for you guys, so that you guys can access it later on whenever you guys require. So followed by this, before we end the session, and before I share this, thank you guys for being a part of this session, where you guys spent nearly 4 hours of time to stay here and learn a lot over this. I hope this was very useful for you guys for TCS digital sessions. And I'm just gonna point it out with the current date, that is 11/10/2020, and I'm just going to share this to you guys. So the link to access this, I'm just going to paste it here, so that you guys can, those who are seeing this can also just use this particular link and basically access the same. So I'm just going to try to put the same on screen for you guys also. separately so that you guys can access it. So that's the entire link. I'm just gonna take a minute. So that's the entire link for our session today. Please make sure you guys go through it, and thank you for being a very nice part on the whole session, guys. And it'll also be pasted in your chat window. Please wait, it'll just be pasted in your chat window as well in a minute. Also, I'll also suggest for any of you guys who are willing to go through more of our programs, as this is just something based on TCS Digital. We offer entire programs on aptitude training, verbal, soft skills, and the whole ordeal of training, that is aptitude technical as well as verbal. You guys can just try going through the description and access our course details through our contacts available in the description. We have huge programs particularly on placement oriented training, which you guys can basically use as well. So with this, I'll just wait for any questions that you guys may have. I'll wait for any questions that you guys may have so that I'll take your questions and answer them right now. So any questions at all, guys? I would love to take them up and answer the same for you guys. All right, so I'm just going to go through any questions that you may have and try to help solve the same out. So let me know, guys, if all right, so let's go through the questions. We have a couple of questions. That is one which is one of you are from EC branch. Is it necessary to know all of these all languages to attend interviews? That is C, C++, Java, and Python. So here's the thing. When you guys want to go through all of these, the basic idea is your entire interview process. Most companies, when they ask, they generally expect whether you're from EC, Triple E, mechanical, civil, or biotechnological, whatever it is. Most companies, including TCS, Wipro, all big companies, Infosys, everything, as well as many other companies, put up their technical MCQ interviews mostly in C. But recently, most big companies have moved, stating that just C is not enough. We're going to have all our MCQ part of interviews in C, C++, and Java. So my suggestion for those who are attending interviews of most of the companies which will ask from C, C++, and Java, it is good to know all of them. In our training program, we have around 30 to 35 hours of pure technical training on C, C++, and Java itself, which you can go through as well. But the main idea, as stating, is that most companies do ask in C, C++ and Java together. And if you want to go through Python, there's only one or two kinds of companies that generally ask in Python. That is, companies hiring in data science, or companies particularly hiring in the roles of automation. This is where they may expect you to know Python beforehand, but except these, it's only C, C++, and Java, which is pretty much compulsory requirements. So thank you guys for being a fun part of this session. I hope I have been able to answer your questions, and I hope I have been able to go through as many things as possible for you to easily solve whatever is required within TCS Digital. And I hope you guys do it well. Good luck with the TCS Digital that you guys have tomorrow. And for more videos, more course details, everything, subscribe, click that bell icon and everything. And we'll catch up possibly in one of our next session, guys. Thanks for being a nice bunch to attend nearly 4 hours of sessions. Have a good night and good luck for tomorrow, guys.